Okay. Okay, so let me get started with my presentation. The topic I would like to talk about is, so as shown as this slide, the BSD as a foundation platform for nationwide semiconductor education in Japan. First of all, let me introduce myself. Then I am Hiroki Sato, a Japanese PVC commuter for a long time. And I'm working in various areas, including the kernel, the user land, and documentation. And currently one of the core team members and Dokken team members. And my talk today is related to the semiconductor education. And probably you wonder, what is the relationship between the semiconductor education and the BSD operating system. So in short, I am involved in a project that related to the semiconductor education in Japan. And the Japanese government wants to build up the servers that student can use as the tool for education, so the semiconductor integrated circuit design. So they want to have such a infrastructure for the students. So I'm in charge of build that kind of server. So I wanted to use the BSD operating system for that. So I want to share what is required for the education, so especially semiconductor education, and how the project works is going. And of course, I have a good number of budget for that, about 0.5 million US dollars for the hardware budget. And so I want to put all of the money to the BSD related things. So that is the rough outline of this talk. But first of all, I would like to explain the specifics about the integrated circuit design. What is the design and what is required, what is the history, and what is the current status, and what the Japanese government wants to do. So that leads to the current ongoing project that I can use BSD operating system for. So for this, probably in this room, most of them are software engineer, the software background. So let me explain what the circuit design is in academia and the industry. So probably you already learned what the electrical circuit is in the junior high school, high school physics class. And probably you can see you have seen this kind of diagram. So this is called a circuit diagram. You don't need to understand in details, but the diagram is something like this. But I want to define the electrical circuit as a collection of electrical components connected to each other. So you do not need to dive into the technical details of this diagram, but you can distinguish the connection and components. The components is depicted in the circuit symbol like this, and the node is the connection point between the components. So electrical circuit can be characterized mathematically in the graph structure, and the node, and the edges, and component. Component forms the edges actually. And the physical amount, in particular voltage and the currents are defined for nodes and edges. The node has voltage, edge has current. So this circuit diagram has the various components. Again, you do not need to understand, but these are component symbols and connections are there. So 3 nodes are defined in the circuit. So, let's move on to the topic about what is the circuit actually. So especially a function of the circuit. You know well about what is the program, what is the program for. And the program can be defined as an information processing machine in a simplified computing model, including the input information and the output information and the processor intermediate between the two information flow. So the program can be designed to accept the information and process it and generate the output depending on the purpose. And to design your program, you usually use the programming language to describe your purpose, your goal. And the described, so your program must be translated into something that the processor can understand directly. It is called the binary or machine code. And a machine code is a sequence or an array of the processor instructions. It's just an array of binary values. And the binary values for the processor is actually the inside the processor that represents the voltage change on the address bus and data buses. And every processor have address bus and data bus inside. And processor instruction, the binary value is corresponding to the voltage high or low on the address bus and data bus. So a processor control logic will fetch the very first instruction when turning off the processor. The program counter initialized and some memory address is pointed. And the control logic will fetch the very first instruction and put the value onto the buses. And the change of voltage will trigger the data manipulations or data transfer, but that will be that are performed by connected circuit. They that are responsible for the corresponding manipulations. So the registers and the memory devices, the I/O devices are connected in parallel to the address bus and data bus. The instruction, so the specific instruction will trigger one of the devices. So all of the manipulations are implemented at the circuit connected to the data bus and the address bus. This is how your program works. And on the other hand, if you can design a circuit, that means you have to design the circuit as an information processing machine in the same way, but the building block is different. Your program's building block was the processor instruction, but if you use a circuit that consists of the electrical component as an information processing machine, the input is the physical amount that it's a voltage or current, and the output is also the voltage or current. So you have to accept the generated information in the form of the voltage current. And the building block is the electrical components. So that means you have to know each building block's characteristics precisely. So on the left side is a list of components, and the right-hand side is the corresponding characteristics of the voltage, the current. So this component register defines the relationship between the voltage and the current. And the capacitor also defines something, and the transistor. This is N-type MOSFET. It's popular in the processor, but defines a more complex equation. You do not need to take care of this kind of equation, but you have to understand here the abstraction here. Abstraction here is these elements have linear or nonlinear functions between the voltage and the current around the components. And voltage can deliver the voltage or current can deliver the information. But this is a bit complicated for a design. So if you want to design a computer or computing circuitry, another building blocks are considered and prepared in the circuit domain, design domain. So this is called the abstraction for Boolean arithmetic. So currently, so today's computers utilizes the Boolean arithmetic extensively as a foundation for the functionality. But the circuit can do Boolean arithmetic in this way. But the Boolean arithmetic uses the input and output value as Boolean, so 1 or 0 or the high or low. So it does not fit with the voltage change. A voltage change have continuous time and a continuous amplitude. So adding another rule that the voltage have only two information, the voltage high and the voltage low. And the input-output characteristics is defined in a Boolean function like this. You can design the transistor circuit. So this circuit, you do not need to understand the details, but this realizes two input, one output, logical or arithmetic operation. If the x1 and x2 and the y is interpreted as 1 or 0. So this can be used as a building block for the Boolean arithmetic, and this symbol is often used as this circuit. So designing the circuit means these two types of abstractions to realize your goal. But the designers do not use this kind of mathematical functions and the hand calculations for the larger circuit because it is too difficult. But the older age and the professors do like the math functions and the hand calculations, and probably I can design the circuit without any computer. But in industry, people usually use the computer to understand or design the circuit. So for these two abstractions, you have to have the machine-readable representation of the circuit. So there are two representations of the circuit used in the industry. So first one is the netlist. Another one is the hardware description language, just like a programming language. The first one corresponds to the first abstraction, just the connection of the electrical components and the linear and nonlinear functions between the voltage and the current. So if you have two components like this, and the input is voltage 1 and the output is voltage 2, the experienced circuit designer understand what this is for. And this is a low-pass, pretty basic low-pass filter. And if you feed the information as voltage at the V1 node, for example, you can feed the audio information into V1 using a microphone. And from the V2, you can get the lower frequency only. So higher frequency is filtered by these two components. And that operation is described in this equation, but it is a bit complicated. But the circuit designer understands this combination and this characteristics generated by two circuits. But in the computer-aided design, this circuit is represented in the simple text file like this. This file is the component. One line means the one component. So R is here and C is here, and the next two columns means the node number. So you can node number and node level. So V1 is a node level, and V2 is another node level. So these two lines, simple text file, can represent this connection because the V2 is used commonly for the R and the C here. And the 0 means the ground level. So this form is this. So this circuit diagram is corresponding to these two lines. And 1K and 1U means the component value for the R and C here. So you can use this representation to simulate the voltage and the current. So the circuit simulator can get this representation as an input, and change of V1, the simulator output the change of input the output characteristics of this circuit precisely. So to design this circuit, you have to understand the characteristics in a mathematical form, but computer simulation, using a computer simulation, you can get actual results without using any components. So this is one of the tools the circuit simulator, a circuit designer uses today. And another abstraction requires another tool because the information mapping to the voltage is totally changed. So for the HDL representation, the design is performed by using the Boolean function. So this is not related to the transistor level, so electrical components level description. So you cannot use a netlist directly. So the higher level representation is used in a form of the just like a programming language. It is called HDL. So this is actually an example of the logical OR to express the input and output characteristics. This is just like a C function, but OR gate is defined as a module. The input is x1, x2, and the output is y. And the relationship between the input and output is described using the operators. So this is like a C language, but this is not a procedural language. It is rather the functional or declarative language. So this assignment statement does not run from top to bottom. So all of the statement inside the module will be processed in parallel on hardware. So these two workflow is used to design the circuit designer. So the relationship between the circuit design and the software engineer is how this kind of simulator is used and what kind of software is actually used in the industry and the education environment. So before moving on to that, let me explain the circuit design and the semiconductor and the integrated circuit. So this is a real-world example of the circuit. So this is a PCB board and the electrical components on that. So circuit diagram is on the right-hand side, and there are a lot of transistors, but in the electrical products and appliances inside the products, that you can see these kind of small components are connected to each other. So probably you may have an experience on using the soldering iron to create this kind of small PCB board. But this is one of the way to realize a circuit in the real world. But these days, most of the circuit is implemented in an integrated circuit. And the integrated circuit is separated from the circuit design itself. It is just the manufacturing technology for mass production. So as shown in this slide, you have to collect all of the electrical components into one place and connect it to each other. That process is required after designing the circuit to make it realize in the real world. But for using the integrated circuit technique, you can put all of the circuit at once onto the silicon wafer using the printing technology. So this is just like a photo, and a lot of circuit. This picture shows the silicon wafer, and you can see the patterns on the surface, and this is a circuit, just like a print. So just like a PCB on the previous slide, and a single circuit is just like this, and this integrated circuit includes all of the circuit components and connection at the same time. So you do not need to put the components individually, and you do not need to care about the connection. So all of them can be printed at once. And after that, the circuit is packaged by the plastic, the ceramic package, and you can see this kind of black components inside the electric products. So everything is manufactured as an integrated circuit because this is reliable, and this is cheaper than getting all of the components into one place manually. And another advantage is that smaller devices usually the fast and the power efficient. This is because every information is represented in the voltage. And if you want to change the voltage on the surface of the material, the capacitance of the material decides the speed of the change of voltage. If you use the same material, smaller volume shows the smaller capacitance. It means the change of voltage is pretty easy. So if you manufacture the same circuit in half of the area, the power efficiency and the speed will be improved without any consideration about the circuit structure. So the miniaturization of the transistor is pretty important in this industry, and probably you have heard about the process node, like a 16 nanometer, a 10 nanometer, a 7 nanometer, a 2 nanometer. And so smaller is always better as the integrated circuit. So the education kit for the radio receiver these days are something like this. So this is same function that receives the radio wave and convert it to the lower frequency that human being can listen to. But the radio functionality is integrated into one small chip, and you can see that this small component. And yeah, the remaining components are something that cannot be integrated into one place, but the number of components are really reduced in recent implementation. So the intention of this talk is not an integrated circuit class, so let's move on to the software environment of the circuit design. So I explained two abstractions. First one is electrical component as a building block. So it has linear and nonlinear functions for the voltage and current, deliver the information. So this kind of circuit is called the analog circuit. And the radio receiver and the power supply device, probably you have a small device that can convert the out voltage at the power outlet to the USB-C. That kind of circuit is categorized as analog circuit. To design the analog circuit, the circuit is represented a netlist, it is the connection and the component list, and the simulators are time domain voltage change that can simulate the time domain circuit change. And if you want to design this integrated circuit based on it, you need to have software that can draw the circuit pattern on the silicon surface. This is called the physical layout tool. And actually, these two tools are developed at UC Berkeley in the same time frame of the BSD operating system, and the SPICE and the MAGIC are pretty famous at the time. And it's still, these two tools are available as an open source tool. It is a bit outdated, but it is still usable. And for the processor design or digital logic circuit, and the abstraction is Boolean arithmetic, and the circuit is represented in the hardware description language. In this case, voice abstraction needs the integrated circuit design, integrated circuit as a final goal. So all of the circuit design must be converted to the patterns on the silicon surface. So the first abstraction, every component has a corresponding silicon surface pattern. So after the simulation of the circuit and you confirm the function, you can draw silicon patterns using a layout tool. But for logic circuit, the situation is a bit different. First, the HDL representation of your circuit does not have any information, concrete information about which component is actually used. So translation from the higher level description of your circuit to the component level representation. This can be done and mechanically. So the logic synthesis tool is used. It is just like a compiler from the higher level programming language, the machine code. And after that, the voltage can be simulated. So the logic circuit simulator is used to simulate the voltage change over time. This is similar to the time domain circuit simulator for the analog circuit, but the difference is voltage amplitude does not matter so much. 1 or 0, the high or low is used for this logic circuit. So logic circuit simulators omit the details of the amplitude information. And after that, the circuit pattern must be drawn on a silicon surface. But for logic circuit, the situation is a bit easier because the electrical components used for logic circuit is limited to something that can realize the Boolean arithmetic. If you understand the Boolean arithmetic very much, the 3 Boolean operators is needed to represent all of the Boolean arithmetic. And only one Boolean operator can represent the other, all of the Boolean operators as well. So if the circuit has a NAND logic gates as a component and the patterns on the silicon surface, the same circuit cell can be used to realize the much more bigger logic functions. So the building block is only one other case, and you can reuse the same circuit. So this is called a cell-based physical layout. It is automated. So in the design of the processor, you do not need to care about how many transistors used, how many electrical components is used. The design is almost done in the hardware description language level. So the following process is automated by these tools, and you can get the BL silicon. So this kind of effort is almost always done in U.S. in over 40 years. This is overview of the history. But so SPICE I mentioned in the previous slide is started in 1972 at the UC Berkeley. And in the same time frame, the Unix will be written in C and developed. And in the CSLG, BSD Unix is developed in the early 1980 or something. At the same time, the funds from the US government is fed to the VLSI program in various universities in US. So this fund is not directly related to the Berkeley CSRG or operating system development, but then the UC Berkeley has the VLSI project and funded by the DARPA VLSI program. The motivation of this program was the Japanese semiconductor was pretty strong in late 70 to the around the 90. So the U.S. Semiconductor industry have concern about the reinforcement. They need reinforcement of the research and education in the U.S. So they started to build up the infrastructure that is required for more variable semiconductor, more specifically the processor development in university. So the SPICE simulator is improved, and the layout tool MAGIC is developed through the VLSI program. And the outcome was the Berkeley RISC processor. Using these tools for automation, they can design the CPU and the first version of the RISC type CPU in the University of Research area. And at the same time frame, the MIT get the funds for the distributed computing environment. So you know the X Windows system is developed in the 80s, and the Kerberos is also developed in the same time frame. So combining these efforts, the BSD Unix and X Windows systems and VLSI computer-aided tools, these combination are a golden standard for the circuit designer. Because so the SPICE simulation, it needs some operating system or a platform that can hold circuit data and simulation results. But this combination works well, pretty well in the universities and industries. So originally the SPICE and the MAGIC and these tools are developed on the Unix operating system, and still after 40 years, it still runs on Unix, use Unix as a primary platform. So the result is, this is a picture on the surface of the silicon, and this corresponds to the one circuit. But a university can design the IC directly, and the development is accelerated. And the US has still a big player for the CPU design at least. So I mentioned the two lines of the software technology. The first one is abstraction, linear and nonlinear functions, analog design. The SPICE is used, and this is improved over years, for 40 years. But the fundamental part is not changed. This is a small command line utility that reads the netlist, a simple text file, and generate the output that tells the designer what voltage change will happen. So the improvement is mainly for the precision, and the new devices, but the tool itself, in the software technology perspective, there is almost no improvement from the 80s. So there are a lot of commercial version of Spice, and nowadays the H-Spice and the Spectre from the Cadence is pretty common and popular, but the basics of the internal structure is not changed. And for logic synthesis, the first practical version is early 90. Design compiler is innovative one, and that can convert the higher level description to the logical level automatically. After that, most of the processor design is just design of the hardware description language. So you do not need to remember the circuit diagram or voltage or current. You can focus on the arithmetic, Boolean arithmetic level description. So today's requirement for the tools are still in the same as the 90s. So 90s means the era when the commercial Unix was popular. So the target was the core is the common open source environment. So this means probably some of the people here remembered what it is, but this is a standardized desktop environment for the commercial Unix, including Sun Serverless or HP or IBM AIX or something. But if you cannot recognize what the common open software environment is, but you can consider this as the POSIX API and X Windows system and the desktop environment like KDE. So pretty much the normal environment that we are using on the FreeBSD or Linux desktop. But commercial computer-aided tool vendors are shifting from the commercial Unix to another equivalent because the commercial Unix is already deprecated. So Linux is now becoming the standard. So Red Hat and SUSE is a standard platform, but the most important point is their tools are not do not depend on the specific environments or specific Unix flavor. So FreeBSD can run most of the tools without any problems if the ABI is compatible. So the FreeBSD or the other Unix flavors can basically run the commercial tools. But the recent years, the vendors, in the 1 or 2 years, the vendors started to release cloud-based. But this is, there is not much change. There are not so many changes about the core of the circuit. Just released as cloud-based using the screen sharing or just providing a GUI part via web browser or something like that. So nothing that changed for the tool, a requirement for tools right now. So let me explain the semiconductor industry and education related to the BSD operating system. So let's skip some of the slides. And so Japan's semiconductor strategy has drastically changed in these 3 years, and 2 efforts are ongoing. One is the northern part of the Japan, and another is the southern part of Japan. The northern part, we are building a semiconductor firm targeting a 2 nanometer class manufacturing. So Japanese semiconductor technology got stuck around the 65 nanometer, the 45 nanometer. So the 2 nanometer is 3 or 4 generations, huge jump from the current node. But we are trying to catch up with the other world after the so Japanese semiconductor is declining continuously from the 1990s. So this is one of the effort to catch up with the most advanced technology. And another effort is the southern part, and we are attracting the TSMC firm into Japanese in Japan, and two semiconductor firm is already operating, and one is 12 nanometer and another is 6 nanometer. This is just a branch of the TSMC, but these two firms, so Japanese government expect these two firms to reinforce the semiconductor industry in Japan. And the government expects the shortage of the workforce for semiconductor. So this is just an estimation, but about 50,000 50,000 engineers are required. So this leads to the call for the education project in across the nationwide basis in Japan. And I am in the Institute of Science Tokyo. This is one of the big university in Japan in the Tokyo area. And we are preparing the put the efforts for the education into one place and provide the education opportunity to all of the students. So, so the one of the role in the project, my role is to build up the server firm for the remote area tool environment. So the currently this infrastructure is being built using FreeBSD. And the requirement is simple. So as I explained in the previous slide, the software technology used in the circuit simulator is pretty simple. Just the X Windows system, and the students can access to them through the some internet access. So just like using the SSH or using the web browser. So my plan, rough plan is build up the Linux VMs for the commercial area tool requires, and it made available to students and practitioners in companies. And I need to take care of the privacy and the separation between them. So this is a simplified model, and it's not so interesting, but students can access the education system all the time and any time and from any places is one of the goals of this project. So all of the servers in the university and provided to everyone in Japan. So the actual implementation, of course, requires the additional consideration about high availability and scaling, and so computing power for required for the circuit simulation. So I am preparing this structure and the authentication and the screen sharing technology, and these are being under test. And the end user is just need to have HTML5 canvas compatible web browser, and all of them can be done inside the browser. All of the servers are built using the BSD operating system right now. And the challenges are listed on this slide, but I do not think probably an experienced system administrator can do the same thing using their favorite software. So on the FreeBSD, to run the Linux VM, the Beehive is used, and there's some simple tools are running in jail, and there is no problem with stability for the 2 or 3 years experience. And for the scale, regarding the scale, the current target is 200 to 300 simultaneous access. And access control and the method to the so access method is primarily the SSH and single sign-on over the web browser. But so system need to be safe from the malicious student. So because they do not care about security. And some design, circuit design, or sometimes export controlled. So the system must have that kind of capability. And of course, I wanted to introduce some technical details, but there are biggest challenges. This is the biggest one. So this is the chart of the memory price change. So Shika project I am involved in for its semiconductor education started October last year. So October last year here. And this line shows the memory module price in the Akihabara electric town. And as of the November 2025, the memory price has started to go up. And after the 3 months, the 96 gigabytes DDR4 module is rise up 6 times compared to the project starts. So this makes procurement process pretty difficult. So I am currently still finding the servers and available memories in the market to complete the build of the infrastructure. And this is the CPU price, and the CPU price started to rise up last January, and almost double up after the 1 month. And it is still on a high level. So currently I am using the scaled down prototype because the network equipment, the other infrastructure equipment are just arrived this month. So the project is delayed much, and it is difficult to complete the first prototype yet. But the remote desktop, the authentication authorization, and effective VM management are separately tested and currently actively implemented into make them into one place and make them ready for students. So I wanted to report the updates and as the project in progress. And actually, there are some interesting implementation I want to share, but I cannot share that because I need more data for them. But I should have more details before the BSDCan September. Okay, so that's all I have today. So I'm sorry about I'm not giving the technical part so much, but yeah, that's all. Thank you for listening. So any questions? Okay.
For using the graphical design tools, have you found, especially as the schematics get more complicated, challenges with the network-based transport of the graphical interface?
Yes, so schematic drawing tool and the layout drawing tool requires the bandwidth, but the software is designed in 20 years ago, so bandwidth requirement is pretty small compared to the current level of the network. So over internet, we can use the tool without any frustrations. Any other questions? Okay.
We have a microphone.
Do you think you'll have to make modifications to the software to achieve 2 nanometer as you said in the presentation?
So major commercial version of the tools already supports the 2 nanometer or finer grade technology already. So the difference is technology data that is used combined with your circuit design. So your netlist and the technology data, two sets of the data is actually used for the simulation. So if you want to use the finer grain technology, you need a different technology file set, and you use your circuit. So combination of that, then it will be used. So tool itself is agnostic to the size of the process technology.
Do you think AI is going to help with this?
Good questions. So we are currently evaluating the AI-assisted design. So for example, so if you put the design request, such as I want to have the 4-bit counter and the output 4-bit counter, and the output is in a certain form, and you put this sentence as a prompt, you will get the HDL representation, and the agentic AI system can call the place on route tools and EDA tools and the proper ways that you will get the silicon representation in 4 hours and 8 hours, actually.
But how do you verify that?
So verify stage is also handled by the AI. So 4-bit counter is verified in the, after the designing. So, so you can put everything into the workflow in the agentic AI. So some university already succeed to implement a small CPU using the same strategy for the 20 days or so. So it's iterative process, takes a very long time, but current LLM have a lot of information source about HDL implementation. So digital circuits, the AI-assisted design will be becoming popular quickly. But for analog circuit, it's not so simple. So it is still required intervention from the manual intervention. Okay.
For the purpose of education, what do you find are the most significant gaps between the open source tools and the commercial tools that require you to continue to support commercial tools in an academic setting?
It depends on the support from the fabrication service like TSMC or the global foundries. So if you want to order the chip, so you have to submit the data to the fabrication firm. But the fabrication firm provides the necessary information in a machine readable form for the commercial tools only. So for example, the TSMC, the latest technology requires the commercial development design tools, and you cannot use the open source version because open source version doesn't support the specific function required for the such a provided data. So, but some university tries to use the open source only to workflow, and Google is actively working on that direction. So probably some part, not serious one, can be designed only using only open source tools. And this direction is growing right now. Okay. Okay, thank you.
Okay. Hello, everybody, and thanks for coming. I'm going to talk today about supporting Hibernate on FreeBSD. So I am Olivier, and just before starting the talk, I have a slide of stuff I've been working on quite recently. I'm mostly invested into the FreeBSD Foundation's laptop project and to do power-related work. So I've worked a little bit on CPPC, which is a kind of improved CPU FREC. So you can control the P states more finely, and also you can say to the hardware that you want some specific balance between performance and efficiency, and you have the hardware doing the optimization for you. So this is in collaboration with Cheng Yi. I've also been working only in support of S0ix more recently. Most of the work has been done by Emmerich, and that work is targeted at AMD framework laptops. So I revised the power management controller driver to make it more robust and more generic for the different machines we have been testing on. And my aim will be to make it work on Intel laptops to be more useful generally, and also because I own actually Intel laptops, so I'm quite interested in having that working. I'm also working on Hibernate, so this is this talk. I've been working a bit recently on MacDo and MDo, trying to merge a new feature that we have that was done by some GSOC student last year. So MacDo is a way to have credentials transition, but without privileges, according to rules set up by an administrator. And also I've been doing some scheduler work in the background for a long time, but now I'm trying to have much more time on that part, fixing the shortcomings that we have today, and also build plans and now implementation for hybrid, better scheduling on hybrid architectures to optimize more for performance or efficiency, depending on the goals. So let's go back to Hibernate. I'll do a brief overview of Hibernate, what it is and what are the use cases. We'll talk about dumping. How do we dump memory state of the machine to be restored? Then I'll talk also about the bootstrap phase, because obviously that influences what we want to save in the image and which kind of metadata we need. We'll talk also about, because dumping memory, as we're going to see, it's a topic on itself, but we would like to dump something consistent so that when we restore, the machine isn't going to crash instantly. And then this is more an exploration part. I'll talk about snapshot as a way to reach that state consistency. It's just an alternative. I'm not even sure that this is what we are going to pursue in the end, but it's an interesting idea and mechanism that maybe is worth pursuing. So let's start with the overview. So I guess everybody knows what Hibernate is, but maybe not. So this is not a talk about biological hibernation, but more about, so hibernate is basically kind of suspend resume. And so in suspend resume, basically you have to do all these steps, not necessarily exactly in that order. It can be more subtle, but typically when you suspend resume your machine, you want to stop non-system activity, you want to save some context, typically buffers to disk. We'll talk about that a bit later or so. You stop CPUs, or most except one CPU, and you power off some devices or put them into low power. And obviously, when you do the resume part, it's the same steps in reverse. So what's actually different for Hibernate? I've only modified the suspend part. Well, the difference is that we have to save all context, actually, because we are going to power down the machine entirely. So basically, we will lose everything that is not on non-volatile storage will be lost. So we have to save all the state. And the characteristics of Hibernate, so since we're going to power down the machine completely, we maximally conserve power or battery. Another threat, but this threat is kind of is the same as for regular suspend resume. We maintain all application context. And another characteristics with all that is that we have better resume latency than just a regular full boot, where you would have to boot up the machine and then launch all the applications. It's not even possible in some cases to restore applications exactly in the state they were in when you were using it. It depends on the application capability. With Hibernate, there is no need to support anything in applications to restore them exactly at the point they were at suspend. So the use cases, so the most obvious use case is to save battery when you're not using your laptop, or if you're nearing or depleting your battery and you need to shut down, but you want to preserve state because of the better resume latency. But it's not only useful for laptops, actually, it's useful as well for servers and desktops to minimize downtime if you have to power off, because I know you're going to change your UPS, or you know there will be a power supply interruption, so that can be useful to minimize downtime. And the trick is, since we are completely powered off and on non-volatile storage, that maintaining that context can last for as long as you want, basically, as long as you're not changing the hardware or the machine itself. So I'll take a brief detour through ACPI states, because Hibernate often is referred to as S4. So S4 and all these S1 to S4 are in fact ACPI sleep states. They are all these states here are suspend resume states. They are ordered in growing latency. So S1 is kind of low latency to resume. But if you go down, it takes more and more time to resume the full context. So S4 typically, this is where we power off all the devices. There is some kind of platform context that is saved. But S4 is really about powering off. It's not really about saving any image or saving the context itself, the world context of the machine. So that's why S4 and Hibernate, they are not exactly the same thing. Hibernate could be implemented without ACPI support completely, but it can be implemented with S4 support. Actually, it's kind of, there is an equivalence in the head of people. There is often an equivalence between Hibernate and S4 because there was some specific S4 operating mode that I'm going to present just in a slide after that. So just to be complete about sleep states, I'll talk also about other states. So it says that's sleeping and soft off, and then system states. So basically S5 is just power down completely, which we can use for Hibernate as well. And we have also S0. So S0 is the running state. So S0 is not a suspend resume state, and S5 is not either. But they are defined in the ACPI spec, and they have different global states. So G0, G2, all the S1, all the states between S1 and S4 are G1 in the spec. And then now we have suspend to idle near S0. So that's basically we're trying to suspend, but staying in the S0 state. In the S0 state, we are executing instructions. The processor can be put in different states and in deep sleep states or deep idle states. And so that's suspend to idle. But in addition to that, in order to reach greater savings, we can actually hint the platform that we want to suspend, and it is going to save even more power. And actually, this is the modern way of doing suspend resume instead of S3, which is apparently less and less supported on recent machines. So ACPI S4, it's a sleeping state. We detect it with some special, if there is a special ACPI object in the ACPI namespace, which is _S4. But then we have another flag. So that other flag is here to signal the support for S4 BIOS. So basically, in Hibernate, as I said, you have to save memory, but there are two ways to do it. Either the OS does it, or the firmware or the BIOS can do it. Actually, doing S4 BIOS had advantages because basically you don't have to code the image saving part in the OS, which is kind of tricky. And that makes S4 quite similar to regular suspend states. So basically, at some point, you say to ACPI, OK, I want to suspend. I'm done. I want to suspend. And the BIOS is going to save the image by itself. So that was quite popular on early platforms, on laptops from 2000 to 2010 approximately. It's supported by FreeBSD. I've used it on some laptops from that era. It works. But the drawbacks is that, so the drawbacks are that basically it's not anymore supported on recent machines. So we cannot use it. Also, it also had the drawback that it needs non-volatile storage dedicated for that part. And usually that was a dedicated disk slice that you couldn't really use for other stuff. So this work is about OS-initiated Hibernate. So basically, these are very high, the high-level steps. So we save the state of an Hibernate image on disk with the content of memory and some metadata. We shut down the machine. If we have ACPI, we are using S4 to do that. There are a few advantages to do it, but these are at most details at this point. So, and once you want to resume, so we will have a loader that loads the image and gives control back to the kernel. And then the kernel initializes the hardware and resumes the save state. So that looks pretty simple, isn't it? So let's talk about dumping memory first. So in order to have an early prototype relatively quickly, we made the choice to reuse our dump infrastructure that we have in FreeBSD. But that infrastructure exists because it's useful for debugging. So on Panic, you can save the state of the systems and then access it with a debugger offline or after a reboot. Actually, it's something that you can request from userland. You don't have to panic to request that. There are different types of dump. Full saves everything. Text only saves the information you asked for, so you have to go through a debugger or a syscontrol to specify the information you want. So it's much more compact and quick, but it only gives you what you asked for. And there is a mini dump type, which is the default on all architecture now, which basically tries to save only pages that are used. I'm going to come back to that in the next slide. And the dumping infrastructure only dumps to a swap partition. So there's no file dumping here. So we would like to reuse this, at least for a first prototype. So minidump looks appealing because actually we only dump mapped pages. So that seems that, and we can finally control what is dumped or not, at least in theory. But there are some problems, immediate problems to solve if we do that, is that only pages from the kernel map are actually saved, but here, and it's understandable because the initial aim of that infrastructure is debugging. So, but here we want to save the world state, and we want to save also application state. So it's not going to be enough. And additionally, there are some complications. One of them are PG no dump. There are some pages that are not dumped because presumably they are not useful for debugging. It remains to be seen if they are useful or not when we restore the image. So that would have to be audited. So just to make a shortcut, we decided to use full dumps at first because there we're dumping all memory managed by the kernel, but including application memory. So it's not going to be enough for the final product, I would say, because some more memory segments have to be saved than just kernel memory. Actually, in this ACPI specification, it says that there are some specific memory areas that have to be restored in case of suspend resume using S4. So anyway, we'll have to tweak those dumps if we stay with the existing dump infrastructure. So now I've just explained how we could save the image, and now what's inside the image. So basically, we want to save memory, as I said. So the physical chunks for the dump infrastructure, they are in an array, so it's kind of simple to use. That would cover all type of states. Devices are a bit particular because they don't, they have their own state, obviously, but they are managed by drivers. And what we expect is that drivers reflect the state of devices in memory, but we're going to talk about that later and the specific problems we have with devices. And so we save the memory, and we save also some metadata to be able to bootstrap the image. So basically it's, okay, we've saved memory, so where do we restore it? How do we bootstrap the kernel? And maybe other ones that we're going to determine by doing a small detour to the bootstrap phase just a little bit later. So this is what we have to save. And for that, the format to save it, well, this one was a no-brainer, more or less, because, yeah, it's quite natural to use ELF to do that. It's very well supported, and we have all tools to be able to look inside what's inside an ELF file and to check a number of things. So it's really natural. Additionally, in its header, you have some metadata data that are relevant in our situation, such as which kind of architecture that is. There is a type field, so we have a new type for our Hibernate image. We have in the health file, you also have multiple typed segments. So we're going to use one segment per memory chunk with ptload type. These segments, they have specific metadata also provided by ELF, such as size or physical address, so that's perfect for our purpose. And we're going to add more segments, ad hoc segments, for the additional metadata. Okay, so let's detour a little bit by the bootstrap. So now that I've presented the image, how do we bootstrap that? And that will help us see what kind of metadata would be needed and is required in addition to all the information I already presented. So the loader, so for now we have settled, it's also in the interest of simplicity. I don't really know if it's going to be the final solution, but it's a solution we are working on now. So we want to have an EFI loader. Also, yeah, I also forgot maybe to tell that the scope of the project for now is only AMD 64, although in principle there is no real reason why this wouldn't work on all the other architectures, except for the fact that all the low-level stuff obviously has to be adapted. So Konstantin is working on the EFI loader part, which is responsible for loading the image and passing control to the kernel. So for image loading, so basically we have to put memory chunks at their physical address as we recorded it in the image and as it was in the initial system before suspend. Well, that is not going to go well because if you see on the right, this is the memory mapping of the kernel before suspending, and on the left, it's the memory mapping used by the machine after reboot. And the use part here contains EFI runtime data and the loader application data and code. And actually, it's mapped somewhere in the low memory. But the problem is that the kernel actually is using that memory because it's reusable memory, and it would be a waste not to use it, especially now that, as Konstantin reports, there are some EFI runtime data and applications that would consume tens of megabytes, maybe up to 100 of megabytes. So it would be, obviously we use this memory in the kernel. So now we have a problem because that loader that is in the use part on the left it has to restore everything. So basically, it has to overwrite itself in place, because that range is also used by the kernel. So we cannot just copy the pages here. So we use the usual solution for that to have a trampoline. So basically, the kernel, before suspending, is going to allocate a chunk of memory that it's not going to use. It's just a kind of reservation. And once we have that, the loader must be told where the trampoline is, where are the free pages. And then, before copying all the memory chunks in place, it will relocate itself somewhere here at trampoline addresses, so that the copying operation is run from the relocated place. And then we can actually copy all the memory chunks in place at the right physical addresses. So bootstrap metadata, so as we said, so we already said we want to restore memory, and we know where because we have ELF segments with the proper metadata. So now we need a trampoline. So we need to pass pointers to kernel allocated pages. Probably we also need to pass, although I'm not sure if you're going to use it, a small chunk of contiguous allocated memory, because it can ease some operations, it can ease the stack and other stuff. So there are some constraints for that trampoline. It must cover, it must be big enough to contain the relocated part of the loader, but also it should not be at a physical address where the EFI runtime and the application have been loaded. So typically, the trampoline obviously cannot be in the or it could be in the used memory actually, but we are not sure about where the used memory is. So the simple strategy that we have for now is that we avoid low memory addresses until 128 megabytes. And we are going to see if it's sufficient for when testing on different machines. It's probable that we may want to take into account the EFI memory map, so pass it to the kernel, and the kernel would use it to know where the trampoline can be allocated. So, and as metadata, we also need some information about, okay, once we've copied all the different pages in place, how do we restart, or how do we bootstrap the kernel? So for that, we're going to see, we want to establish the kernel map in the hardware kernel map, which is basically page tables, mostly. And we must have some kind of entry point. And so the design for this is that for the entry point, we like to have a minimal interface because we want to avoid having to tell people to update their loader in case of when they install a new kernel version, or if there are evolutions in the Hibernate code. So basically, we want a minimal interface. So we only pass in metadata some critical system registers, and then an entry point just in the form of a stack pointer and an instruction pointer. But obviously, the kernel context is much bigger than that. There are lots of MSRs typically to restore. E4 is for long mode, or in particular 64-bit mode. GSBase is for the GS segment register, which allows to access quickly kernel data. Star and LStar, they are linked to the fast syscall machinery, and there are some others to restore as well. We have to restore general purpose registers because we are not in the here using the traditional C calling convention, and some other usual CPU state. So basically, what I'm saying is that this is going to be done in 2 steps. First step, the loader jumps to the kernel entry point, and then the kernel loads the full context. So that was basically one of the the main ideas from Konstantin to have this minimal interface. Although for security, I've insisted into versioning the metadata because we're never prudent enough, I would say. Okay, so now that we have seen all the metadata we need, let's go back to dumping the memory. So dumping the memory, we have seen how we would like to do it, and how we are doing it actually in the prototype right now. But then there's the problem of system consistency, because we have some constraints for Hibernate, obviously, is that, yeah, we restore the system, but it must be viable and it must work as before the suspend and not crash immediately, or maybe later if you're using some features there. That would be a reliability and stability problem. So for that to happen, we must not have any external discrepancies. So probably we have to check for the hardware, has it changed or not since we suspended. Typically, ACPI helps a bit here, because in the S4 sleeping state, actually a kind of hardware signature is saved by the system and is passed to the loader, and then we can pass it. The loader can verify it before trying to boot the kernel and decide, okay, we are not going to load because the hardware signature is different. Although this mechanism is probably fragile and I think is disabled by default on Linux. So probably we'll have to do that, but by hand. And there must be no internal discrepancies in all of the different subsystems, especially for allocating memory. I'll touch a bit on this in a few minutes. And the other constraint is that restoration failure should not affect storage data. So basically, because we are not sure that we are going to be able to restore. It may be that it will be impossible because of hardware changes. I don't know, you have very bad luck and your hard disk is broken at that point. So, or your hard disk where you save the image. They may also be bugs. So it could be that we cannot restore. So, but in this case, we don't want the storage, obviously, to be garbled. I mean, the regular file systems this time, not the image. The image, obviously, if we don't restore, it's not, we can get rid of it. So, and the problem here is that we have lots of moving states. So the memory is changing all the time because lots of things are running. So how are we going to deal with that? Well, for applications are really the easy part because these are user-land threads, and it's easy. You just stop them, and they are going to stop modifying their memory. So that's the easy part. So devices. Devices, you don't want, for example, to have a request to be in flight to your hard disk or commands where you would expect, for example, some response. And when we wake up the machine, obviously the hardware is not in the same state. And if we have layers that are expecting some response somewhere, they are going to fail or maybe time out or something. And we want to avoid that. So it's important that we quiesce the devices just to be sure, and that DMA transfer are stopped, because that also would affect memory. So that's not that simple, actually. And for the kernel, the main problem is that how are we going to have a consistent view of kernel memory while we are saving? Because we are saving, so basically we could be using memory. So how are we going to manage that? So for kernel high-level state, so system processors or threads, they are not generally stoppable, but some of them are. But really the important thing here is that we can stop them abruptly by stopping CPUs and the scheduler, which we need to do anyway because this is a requirement of our current dump routines. So we will see if we can lift or not this kind of requirements. But at the moment, we have to do it anyway. So really the important point here is that we don't want memory to change. So what we want is to drain any pending requests to devices, and especially to disk, So, and draining pending the requests, actually, it's two parts. It's ensuring, okay, nobody is going to issue new requests, but it's also draining the existing ones. So actually, this requirement is kind of similar to all other suspend resumes. It's not specifically for Hibernate. But I think although we do file system suspension effectively, and we actually sync to disk, I don't think we requires geom. I'm not really sure if it's a problem or not, but let's be on the safe side and probably requires geom as well before suspending everything. So devices, coming back to devices, and that will illustrate also the point about in part about memory. So to suspend devices, usually, well, we have some bus infrastructure. We could call, usually for suspend resume, we just call device suspend on the root bus, and this is going to propagate to all the devices below it. But now we have a problem, because if we suspend everything, well, how are we going to save anything to disk? The disk is gone. So we could suspend, but resume only the disk. But we still have the problem that, okay, we said we wanted to suspend devices to avoid moving state, but then now we have still the disk driver actually running. But first of all, before talking about that part, for devices, we don't, at the moment, we don't have the infrastructure to do selective resume of some devices. That requires powering up part of the device tree, so not only the disk itself, but all the bridges that connect it to the root bus. Another problem that we have is that some drivers are not really drivers. I mean, they are not in the driver, the common driver infrastructure that we have. Typically, all these disk drivers, the most common ones on regular machines, they are CAM-based. So CAM has a device for the SIM, but it doesn't have any device in that framework for all the different disks. So there is no device suspend, device resume. And how it's done then, but in fact, we are using some event end handlers. And okay, that works, but for selective suspend, it's going to be a problem, because we have some handler per disk type. Or it's a problem, it's maybe not optimal, but then that means that we're going to have to power up or power down all disks of the same time, although we only need one disk for the image. So this has to evolve to be usable and to actually only wake up the disk that we need. And even if we do all that, so the disk driver is still working, and is going to make some state modifications. So even in our dumping infrastructure, we use polled I/O, but even in polled I/O, we're using DMA. And actually, for DMA, we're doing some allocations. In particular, if using IOMMU, but also for example, for bounce buffers, although I think that most of them should be allocated in advance. So here, I'm not completely sure, but it seems that we still need some memory allocations here. So how can we solve all these problems? Actually, so we can add some infrastructure for selective suspend resume. Actually, there is a device quiesce method that exists, but there is no implementation. So basically, it's an exercise left for the reader. But what to do about memory allocations? Because if we don't, the problem with memory allocations, that could cause leaks. For example, if we allocate memory that and do not mark that memory allocated in this case, it's not a leak. It's you get freeing for free. But if you allocate before dumping, in that case, it's marked allocated, and you have to free it. And you have to know which allocations took place. And if it's deep down in the stack, in the driver, well, it's not supposed to keep track of that. But the most important problem here would be inconsistencies. If we are marking some areas used, although they are not, it could cause when we do a free, for example, or the other way around, when we do a free, if it's not marked as allocated correctly, because when we're going to dump, we're going to go over all pages, and the memory allocator probably, in most cases, touches a lot of different pages. So we are not going to save a consistent view of it. So that could lead to problems. So to solve that, well, there are two main directions. For now, I've not settled on which direction to actually implement. So basically, there is one way is to have specific code in drivers that would be very much controlled. They would only use some pages of memory that are pre-allocated before suspend, and we would ensure that nothing else is used. So it's kind of a constraint, but it could work because we are dumping to dump devices. These are simple block devices, so with contiguous blocks. So it's doable. The drawback is that you have to do that in all different drivers. So, and this is basically the approach that OpenBSD took. Another approach, so it's kind of an exploration here, but I'll talk about snapshots, because that could be maybe a more viable solution for the long term. So if we could take a snapshot after quiescing everything, but before the dump, well, that would solve lots of problems, actually, because we could restore normal function just after the quiescing part and taking the snapshot. So basically, we could use any kernel code we want, do any memory allocations that we need to, use all the existing infrastructure, so we could dump two files, we could reuse the encrypted machinery we have for dumps. So that the life will be really easier for the suspend part. Okay, that would be nice, but how do we do that? How can we do that? So there are two possible variants, kind of a priori variant where you snapshot all memory from the start. So I'm sure you're seeing a problem here already. How are we going to copy? Where are we going to copy? If we want to save the whole memory, where are we going to take the snapshot? We don't have space, actually. So in that case, we have to make space. So that means we have to get rid of all the caches and buffers that we can. Obviously, we are not going to be able to copy more than half of the physical memory. So let's try not to copy everything that is going to be preserved. For example, we don't need to copy userland memory, which is bound to be the greatest amount of memory used. And actually, this is the variant that Linux has been using for a long time. And so it works. But they say, OK, if you're on a very loaded machine, you'd better have a big swap partition. Because actually, we're going to save the image, but we're going also to deport all the stuff that we will reload afterwards to make room for the copy. So my idea is more towards doing some kind of lazy variant. So we would only copy pages that are modified after the snapshot point. But to that, it's in a way, it's much more low level because you have to change the kernel page tables for that. Basically, you mark them read-only. If you write to the page, OK, the page fault handler is going to actually make the copy at that point. And then you restore access. The only thing is that if you call this machinery from interrupts, obviously, you're not going to be able to allocate memory. So we can support that with pre-allocating pages. Because then, once again, once we've taken the snapshot, then our goal would be to use the system as usual. So everything will be re-enabled, and we can take interrupts. So all subsystems are going to function, and we can have writes basically everywhere. And so it's more low-level approach, but at the same time, it's more generic, because here you don't have to care about which driver is writing memory or allocating memory and at which time during the dump. So it seems more generic. Although it's not without difficulties also on the low-level part. So these are the common traits of these two approaches, of any snapshot approach. Actually, you have to determine which page that need copying. You have to allocate memory for them. But then you have to maintain a mapping between original and copies. And what you do is that the copies are the pristine state at the snapshot point. So when we are going to dump, we are not going to dump all memory. We are just going to dump the copies for those that have been copied. So we need to have that mapping to know which pages we want to dump, actually. So on dump, it's the copies that go onto disk. So yeah, to conclude, so the status of this project is that we are in a very early phase. I was quite optimistic when writing the summary for this talk, because I expected maybe we could ask for testing, but no. In fact, what happened also is that we stopped working on it for maybe a little more than a month to work on other stuff. So it made less progress than anticipated. But it's still a high priority for the laptop project, so it's now ongoing again. So we have an early dump prototype that produces an image. There is work ongoing by Konstantin on the EFI loaders, who we had to have some exchanges about the actual interface and calling conventions. I have some code sketch for kernel bootstrap, but it's very preliminary. Actually, it's wrong in some details, but it's kind of easy to fix, or I think it should be easy to fix. And then there is the quiescing high-level kernel state, which is the geom part, essentially, but maybe some other parts. And also the device, how are we going to quiesce the devices? And then the next step is also to finish the analysis and decide on the precise consistency approach. Probably I'll talk to some other experts I've been already talking to, actually, to see what's feasible or what they think about the different approaches. So I'd like to thank Konstantin for his inputs on low-level stuff and working on the loader part, and to Warner, who produced a lot of answers, or at least ideas, to lots of questions I had. So thanks a lot to them, and I'm sure I'm going to bother them a lot in the coming months too. But yeah, I think it's a very valuable project for laptops. So I'm done. If you have some questions or remarks, yes?
Hi, I know that on Linux, when you're using ZFS, you have to disable Hibernate, because I think from what I remember reading, the ZFS freeze procedure doesn't fully stop disk activity. So when you finish, when you're taking the snapshot, you end up with a snapshot of memory of what the disk state is in the future, or in the past, compared to what's actually on the disk. So have you looked at how this is going to interact with ZFS yet?
No, with ZFS, no. I haven't looked at that. Although normally we have, actually, it's true that on my laptops, typically I'm not using ZFS. I'm using UFS in preference. So I have, yeah, I didn't look really at that. Normally we have an infrastructure to stop file systems, but also to, more than that, we have a generic infrastructure to stop sending requests to the file system layer. So it's only part of the drain, as I showed, because there are two parts. Okay, you stop that, but you have to drain what's in the pipe. So yeah, that part for ZFS, I don't know.
Okay.
I heard actually about the problem with Linux, with ZFS. For many people, I don't know what's the source or how it's supposed to work. But my request was, question was somewhat related, but not exactly. You mentioned flushing caches. I suppose it would be much cheaper to actually drop them than write to disks. But I don't remember if EZ has any method to actually requests file system to drop caches. Linux
I don't think so. Actually, I don't think so. It's part of the.
it would be cheaper to actually, from all perspective, to just tell ZFS to drop
Yeah.
as much as can be.
Yeah, surely. Although, yeah, Werner was saying, okay, we can drop typically user data that we can reload. For metadata, it was more on the side of maybe if we can keep them, maybe we keep them because it's longer to reload. But it's not essential either.
I suppose the restore process from BIOS should be pretty slow, considering, for sure, with UEFI not as terrible as before, but still a single thread that's one disk, and you may need to reload how many gigabytes.
Yeah. So choosing EFI loader to do that, actually, yeah, I think Konstantin decided that for simplicity, for the prototype. I'm not sure. I mean, all the other systems, such as OpenBSD, for example, or Linux, they're not doing that. They're booting a real kernel, and it's the kernel itself that will load the image. So, yeah, I'm not too sure about if this could have advantages in terms of loading the image, because if you're concerned about the time of loading, or the time it takes to load, or
Loading kernel would make you then the requirement to replace one kernel with another kernel.
Yeah, it's another kind of worms, yes. Yes?
To what Matt is saying, ideally you dump as little as possible that you then restore at the time of immediate resume. That you'd rather have the system start working, and maybe you do kind of thrash and you're like command paging a bunch of stuff in, but you're already at least running somewhat while you're doing that. So from the user's perspective, the system responds a lot quicker. You can minimize how much you have to write out. So I do think, yeah, probably that is what would fix Linux as well, is you need a way to flush the file system state to make the file system logically free us. It's not just sufficient to the disk queues, you have to make the file system kind of go along with it as well. I mean, I see all sorts of craziness that S4 would have compared to S3, which is like in a NIC driver, I don't know that all our NIC drivers actually free all their rings, and you probably want them to for S4, because like the hardware has certain assumptions about where the indices are in your rings, in your scripter rings, right? And that's going to be true when you resume. It is kind of an S3, it can be, maybe not, but like you have to be more intentional about throwing away stuff. The more stuff that you can throw away, you have all the drivers, and as many substances as possible throw away, the better. And I think that's what Alexander is hinting at too, is usually firmware disk I/O is not the speediest, so that also helps if you make that smaller, because you can probably be working currently when you're basically doing a big giant command page in after you resume, compared to a very synchronous paging in through the bootloader kind of phase. And I think depending on EFI is fine, especially because if we were assuming EFI, I imagine other systems are trying to make it work without EFI, in which case you're assuming that you have nothing, and so you have to load a kernel, because pre-EFI firmware is pretty terrible in that case. I had another question, but I know you had a question too. I don't know if you want to go first.
Sure. So my question is, for applications with in-memory secrets, is that a concern for Hibernate? And if so, what can be done about preventing secrets being written to disk during Hibernate?
Yeah, of course. So that means basically if we dump, and that's what we're doing now for the prototype, but if we dump the image in clear text, obviously you can find all secrets there. If they are not being sanitized, then there is no reason there are, at least from applications. So yeah, we want to encrypt the image. So then we already have an encryption infrastructure on top of the actual, the current dump infrastructure. Thing is, yeah, I'm not completely sure if we want to stay on that, on top of this or not. But yeah, it's a goal of this project that we're going to save an encrypted image, yeah.
If you already have encrypted swap, will this work with encrypted swap to forego that additional encryption and just rely on the encrypted swap that you get with CFS from the installer?
Yeah, probably. The trick is that, as I said, we are resuming from a loader and not from the kernel. So then we'll have to implement the same kind of encryption in the loader, which is completely doable. But yeah, it's something to to factor in because it's going to take a bit of time. But yeah, it could be possible like that. I'm not too sure about what to say here going forward because I mean, saving to dump partition seems to be enough for most cases, I would say. But there are systems that save to a file. So what do we do if we save to a file? I mean, which kind of encryption? And anyway, we have to be sure that on the loader side we are able to decrypt. So yeah.
That's my annoying question. Is you talk about, you compared to mini dumps, and crash dumps have a luxury that S4 does not have, which is crash dumps have a luxury that we don't care too much about user data. We're already toast. So we can happily overwrite swap and lose whatever user data was in swap.
Yeah, exactly.
You don't get to do that.
Yeah.
So like you have a constraint that if your system is swapped a bunch, those are all, they're not file back pages. That's why they're swapped. So you have to save all that stuff. So it's not just RAM you have to save. You have to preserve all your non-back stuff that's already sitting in swap as well. So I mean, I don't know if it's just that sometimes hibernate can't work because you don't have enough room in essence, or if you
I think.
That the thing that's most reliable is you need to have a separate dump partition, separate from swap.
Yeah.
Like the size of RAM.
That's exactly what I was going to say.
I would say that's a decent requirement. Try
Yeah.
to work with swap if you can, but otherwise you're in second situations where you can't do this.
Yeah, no.
You kind of enough dedicated space to go to your RAM probably to be reliable.
No, exactly. It means I don't think we want to make that a requirement, having separate swap partitions. But then, obviously, if it's a swap partition that you are using, then yeah.
Let's say if you have a dump partition, not even just like its own
Yeah.
separate, not used for swap at all.
Yeah, and we can advocate for that and say, okay, if you want to be sure to be able to suspend, it's
Yeah,
best to.
I would set
but-
aside a partition to make sure that it always works.
Hmm.
Probably, especially as an initial prototype, it would probably make your life substantially easier to not have to worry about this problem because you don't have to deal with. You can effectively force as much crap out the swap as you want, and if you want to stage your snapshot, you have a dedicated place to stage it without having to worry juggle that you're also trying to not overwrite swap data.
But actually, we're happily dispensing with that in the prototype. I mean, if you're using swap, we'll happily just crash it completely. So it's, yeah. but of course, it's something that we can't do in the final product. Yes. So yeah, maybe recommend a separate partition. But I should say that it really depends on your workload. I would say I expect that on laptops, in most cases, most of the memory will be taken by user applications. So, and these you can, apart from change pages, but all the text. So it depends on how much data they're using, actually. But
I guess my point is, especially when you're prototyping your first implementation, if you had that as a requirement initially, that later you relax as you refine the implementation, then you could do something kind of like, let me describe, you already have a place to dump it, and just stage your snapshot and periodically resync pages off to your snapshot that sits over a special partition. Does that make
oh, you mean a kind of iterating process, just for consistency, or?
Well, so you talked about some of the problems of how much you can sling on the system while you're still trying to write out the dump. If you have a dedicated thing that's not swap, you can stage your initial memory snapshot to that. You can periodically like restage pages as you detect them to there.
Yeah, sure.
What Linux described of still paring down as much of your RAM you actually have to dump as possible. But then your second copy doesn't be RAM. You can actually do your second copy straight to there.
Yeah, it could be a possibility, yes. Yeah. Any other questions? Yeah.
Have you put any thought into the user interface you will need to feed a key back into the system in order to recover an encrypted?
Well, not that much. What we have now for the existing dump infrastructure is that we have some userland program saying to the kernel, okay, this is the key to use.
Repeat the question for the 3 volumes too.
Oh, yeah. So you were asking how could be the life cycle of the encryption key?
Have you put any thought into how user feeds a key back into
Yeah.
the laptop?
How the user feed the key into the laptop. So yeah, for the suspend part, it's kind of easy because we already have something where we feed a key to the kernel saying, okay, this is the encryption key for the dump. Although, yeah, it's debatable if it's a good idea to do it early or not.
You have this really, really trivial bootloader, right? The very, very simple entry point, but you need to get some kind of input from the user, like a password or, you know.
Yeah, or some USB key or key dump.
Or a FIDO key or something.
Yeah, that's why, yeah. For that part, we haven't given it much thought, but we know that with the AFI, as an AFI application, you can access, for example, a USB key and load a key from here. So I don't think it's a particular problem, but we did not do it yet, so we have not done it yet.
Okay, so you're thinking of doing it through an EFI application?
Yeah.
Rather than in the, after the really trivial bootloader, right?
Yeah. Any other questions? Well, thank you very much. And please come if you want to discuss about that. Don't hesitate to come. And with your wild or crazy ideas, it's really nice to have a chat. And sometimes we discover things we didn't see before, so it's nice. Thank you.
All right. Hello, my name is John Baldwin, and this talk is going to be the kind of third talk in a series I've been doing. I started it in Canada last year and had the second installment in Euro in the fall on kind of the topic of linkage, some kind of specific to ELF, kind of linkage in FreeBSD land. And I'm going to go as fast as, well, I'm going to get started because I have a lot of slides. If you have questions, you can ask them. That's fine. We can kind of do them during the talk, I guess. So in general, with all these talks, the problem that we're trying to address is source code likes, as we as programmers, we like to talk about symbols in source code, data variables and functions and so forth as symbolic names. But computers or CPUs at least don't operate that way. They name things by addresses. And a large part of what we're doing in linkage is, and in the compiler to some extent, is how we map symbols to addresses ultimately. So the example here is, that I've used now several times, is you have, we call it main calling printf in this code. That's how we think about the things. But in the machine, it needs to know what address do I branch to inside of main when I want to invoke printf. So today, for this talk, I'm focusing on a topic called thread local storage. My previous two talks have focused almost exclusively on symbols that generally have a single fixed address, things like global variables where there's a one-to-one mapping between names and addresses. But when we added threads to Unix in particular, but also other systems, this required a new type of symbol. In particular, we have certain types of symbols where we want different values in each thread. An example of this on Unix systems is errno. So if you think about errno, it's a global variable in essence, but you really don't want different threads to share the same value of errno. If you're invoking a system call and you want to be able to check errno after it returns failure, you need that to actually be the errno from your system call, not the errno from some other thread running in your processes, the system call that happened to invoke at the same time. So in order for this to work reliably, the way that we all expect errno to work, it has to be stored per thread somehow. And there are other types of variables that threaded programs may need to store per thread versions of. So it's not just limited to errno, it's kind of errno, it's a general problem. If we implement this, one particular difference about per thread variables is their storage is not kind of global to the process, or it's not set at process or exec, for example. Instead, you have to allocate the backend storage for each of these variables when a thread is created, and you release that storage when a thread goes away. But before we go further into ELFI type things, let's talk about errno and how errno works. So before the introduction of threads, errno was pretty straightforward. We just have a single global variable. We declare it in the header as an extern. That looks kind of nice and reasonable in the way our mind maps to it in C. Then back in 1996 in FreeBSD, in this particular commit, we made errno a little more complex. We have this different version now that if you happen to define a macro underscore thread safe, now errno is actually mapped to this expression that indirects a call to a function, and we've defined a prototype for this function that returns a pointer to an int. And then about 2 years after that, we said, we're always going to do this indirection where we're always going through the function. So not quite an extern enter. Or an extern int. So what does this actually do? Well, now every time you refer to errno, we actually call this function underscore arrow, and we get back the pointer, and we reference that pointer to actually find the address of errno, either to read it or write it. Okay, yeah, so that's the errno is stored in per thread storage. So how does that actually work in practice? So today, this bit that used to live in libc in FreeBSD 15 and later, it lives in a library called libsys. So we have a couple of things in this thing. First, you can see we have the actual error function calls a function pointer called error selector, because we can't have enough branches in everything that we do, right? The CPU loves us to death. And initially, this function pointer points to a function called error unthreaded, which returns a pointer to a global variable, which is effectively the moral equivalent of the old global errno variable, just with a different name. So we do several branches to return the same thing we would have originally if it was normal C, and we just looked up the address of errno and got, or NA got. So what about when you have threads? What do we do now when you have threads? So in the thread library, we have a different version of a resolver. First of all, we do have a reference over to the version from libsys that single-threaded programs use, which we'll use in a second. And then we have a different implementation of a function pointer that the error selector thing can be pointed to. So a different version of how we handle error. And so we do a couple of checks. The first check is to see, have we bothered to create any threads yet at all? If not, we're going to fall through off of the end of this if into the bottom of the function and return a pointer to the global over in libsys. In particular, this means that if you've linked libthur, or if you DL open libthur at runtime, which is where all the pain and suffering truly comes, you still use the same error node value as if you were single-threaded and hadn't linked against the thread library at all. Or if you have created threads, so this thur initial global is not null, we also check to see, well, which thread are you? If you happen to be the thread that's running from main, we still need to let you keep using the thing you were using from before you created any threads. So in that case, we still actually fall out and use the global from libsys. But otherwise, if you're a thread who's not the initial thread running main, then we return a pointer to a member of a private struct that belongs to the thread library. So every time you access errno in FreeBSD, whether you're reading the value or anything, or passing the value to a function like errc, every access involves calling a function, getting a pointer from the function, and then dereferencing that pointer inside the generated code that the compiler emits. And the compiler has to repeat that every single time you call errno. So if we had to write this much code every time we needed to add a new TLS variable of some kind of thing, especially as an application developer, that would really suck. It wouldn't really scale very well. Oh, and by the way, where would you put the storage for this? Because currently, the thread library knows the layout of this private internal structure that defines kind of metadata about every thread. So it has the ability to allocate some storage in this internal thread structure for errno, but we can't expose that to application developers. Like, that would really be terrible. So POSIX or pthreads, they have a thing called pthread keys. That kind of solves the second problem for you. They'll kind of hide dealing with the storage and manage allocating storage for each thread object for you. But it has all the terrible properties of the first part of my bullet point, that it's a bunch of code to write. You have to manually kind of maintain these contexts of a way to name like a chunk of per thread storage, and it's really clumsy to use. Not near as convenient as just using a normal variable in C. So ideally, what would be nice from an application writer, or anybody writing C really, or C++, is instead of using kind of the way we hack errno or POSIX thread keys, is if we had some way to natively name symbols as being thread local, and just declare them in C that way. So for example, if we could add something like a thread modifier, a different type of storage class on variables to say, hey, this thing is actually per thread. And then transparently, a lot of magic would happen, and every access to foo would do the right thing. In particular, in this model, every thread would be allocated some kind of block of storage to hold all the different per thread variables that you have. And what we would do on the toolchain side is we would basically associate foo not with an address, like a global address, but foo with a relative offset inside of this chunk of storage. So there's actually like a per thread copy of foo at the same offset inside this chunk of storage. And every time you access foo, we go find for your current thread, where's my block, where's the right offset, and that's what resolving foo does. So how do we do this in modern C? So in C11 and C++11, mostly, we have this new storage class called thread_local, not called thread because that term is far too overloaded already. That allows us to do pretty much what I just described, that we can declare variables as using per thread storage. And in particular, and GNU C even supported this in older language standards. They had like a GNU C specific keyword __ thread. So we've been able to actually do this for several years. But how does all this work? First of all, the toolchain and the runtime must both cooperate to implement this, because they both have to know about how we're going to manage offsets and some things, how we're going to do the storage. To aid with this, ELF has grown various extensions for how we describe TLS variables, including new types of relocations, both static and dynamic, which I won't cover in too much detail today because there's too many of them. New types of sections and segments that live in our ELF files. And then the runtime loader has to do a fair bit more work than it has to do for normal non-TLS symbols. It has to arrange that storage is allocated for all these per thread symbols so that each thread has its own chunk of storage. And it also has to assist with how do we manage those offsets, a kind of virtual address space per thread that we map per thread symbols onto. And that makes everybody have to cooperate. In particular, one of the painful things here is the fact that we allow the threading library to be DL opened, it causes a lot of suffering, a lot of suffering in many parts of the system. And this is one of yet another place where this causes suffering, in that the runtime loader has to kind of have hooks to allow the thread library to override behavior from libc with how we allocate all this stuff. It's just more headache. So first of all, let's look at some of the else changes, starting with else sections. So here's like a normal object file I think I talked about last year. You have a couple of sections in the thing that comes out of your compiler, like read-only data and text for your functions and data for your writable or your global variables that start off with a non-zero value and BSS for things that are zeroed. And in ELF, we're going to add a couple of new sections to help with this. The first one is called tData, which is kind of morally equivalent to .data, and that it's describing the kind of initial contents of writable per thread variables that don't have a value set to 0, just like .data does. And then we have a tBSS, which are per thread variables whose initial value is 0. So just like we have data and BSS, we have tData and tBSS. But note that we don't have equivalents for other types of sections. In particular, things that are read-only, you don't actually need a separate copy of per thread because they're going to be the same in every thread anyway. It's only things that are writable that you have to do this. So that covers both like object files and things that come out of the linker. But for things that are linked out of the linker, like binaries and kernels and shared libraries and so forth, ELF also defines a new segment. So here we have kind of a sketch of the C runtime library. It's also got the same kind of sections normally of row data, text. And in this case, because we've added some TLS variables in libc, because JMalloc at least has some, we also now have tData and tBSS that live inside this library. So tData is mapped into memory normally. It's kind of copied into your address space because it's covered by a PT load, just like .data would be or .text would be. tBSS is kind of weird and not done exactly the same way. And then we have this special ELF segment, PT_TLS, which covers both of these sections and effectively describes how much space do you need for this given library or binary for per thread variables that it defines. And it doesn't trigger loading anything into memory as much as it's describing a property of a chunk of the address space, similar to how PT GNU Railroad works, which is just like a property of a chunk of address space that's already mapped by PT load. So this initial memory range covers everything you need for, how am I describing this? Oh yeah, everything you need to kind of build a template form of the thread local variables for a given thread for the variables defined in this library, so that you have a place when you're initializing a thread, you have a template to kind of copy into that thread's storage that we allocate for it. We'll walk through that in a little more detail. And then what makes things start to get a little more fun is every binary or shared library can have its own TLS block. So we don't just have one of these necessarily. So we have these TLS blocks that are tied to a binary or a shared library. How do we actually assign those per thread storage? So in a static binary, we can allocate a single block of storage for every thread. We know exactly how big it is because in a static binary, there's only one thing, one kind of library or one executable line around. And so the size of the PT-TLS block for that one binary tells us exactly what we need. And we can initialize every thread by just cloning this PT-TLS map block. So initially in the C startup code, some of the stuff that runs before main, we will allocate storage for the initial thread that's running main and then do a copy to kind of set up the initial values of that before we get into main. And then anytime a thread is created, we do a similar kind of dance where we'll allocate some storage for the thread that's sized to this, and we'll do a copy. Okay, so that's, yes?
Does this mean a single thread program will have two copies?
No. in a single-threaded program, you never created another thread.
But PTTLS will copy.
Yes?
So it will have to copy.
Kind of. We don't. BSS is a little special, but yes, in essence, you have 2 copies. And this one is effectively read-only, if that makes sense. But yes. It gets worse, but it's okay. So in dynamic libraries, we have the opportunity to have more than one block of TLS storage, right? Because a shared library or a binary or multiple shared libraries might all decide they declare some TLS variables. So that means that the amount of stuff we have to allocate now is bigger. So we have to look at the set of libraries we depend on in a dynamic binary, like look at all the DT needed to figure out what shared libraries it depends on when we're initializing the address space in the runtime loader, add them all together and figure out that's the size of the PTTLS block that we need. And in addition, the runtime loader has to figure out kind of assign offsets, relative offsets within this for every block. So like the binary, it turns out it's going to get the first chunk of address space, and after that, we'll append libraries in this kind of logical address space. Then thread creation after that is pretty similar. We just have a bit of a larger template. Now we've got every time the thread is created, either the initial thread allocates its storage or during pre-thread create, we've got to allocate a block that's sized to this and still do some kind of copy to initialize the state when we kick off. That was the easy version. But then comes DL open. And this is where things get sadder and a little more complex. So a DSO that you open at runtime might decide that it also wants to declare some TLS variables. And we have to do something about that. This means that per thread storage we have for the threads that already exist when we call DL open might need to grow to account for the fact that we now have more TLS variables that are accessible if the thread calls into a function in that library. Oh, go forward. So one approach you could take is maybe the runtime loader could try to add some padding, make that block a little bigger. But then what happens if you DL open enough things and you run out of space? It's all kind of sucky and terrible. Plus, you've also bloated space you may not need if you actually do this. We don't get to pause the world while we're doing this. Other threads still need to run while we're doing DL open. And all the pointers to all the TLS variables we've already assigned for every thread that's already running has to stay around. We can't change it. So we can't allocate a new, bigger array, like with a realloc, and just move it because, I don't know, some thread might be inside of memcopy, and one of the arguments to memcopy was a pointer to a TLS variable, and so it's doing loads and stores, and we don't know it's a TLS variable because it was a delegated argument in a function call, and it's in the middle of the loop, and So these are some of our constraints. So what's a little more indirection between friends? The solution to DL open, as in many problems in computer science, is a bit more indirection. So now, instead of only allocating a chunk of storage for every thread, we're going to allocate an array of pointers called the dynamic thread vector, or DTV. We have many acronyms in TLS land. So every mapped object, or binary, that defines TLS variables, including the binary or shared libraries, we're going to assign them a unique index into this array. And the array is going to hold a pointer to the per thread storage for the TLS block for that object. So I got pictures. It'll help when we get to the pictures. And during DL open, there should be a little asterisk on this last point a bit, but we'll get to it. Effectively, during DL open, the simple model you can think of is the runtime loader is able to grow these DTV arrays, because those arrays are kind of internal and private. We can safely realloc those arrays to add a new entry and then populate that entry with a chunk of additional storage that we've allocated. And because we can allocate additional storage on the side, we don't have to change the pointers for all the existing thread TLS blocks we'd already allocated. All right, I promised pictures, it'll help. All right, so let's have pictures. So we have a thread, and the thread's going to have our little array of pointers, a DTV. So in this case, the first entry in the DTV is a generation count that we're going to use for various optimizations and to know if we need to grow it. We also have a size, because it's important to know how many entries are actually in the thing. And then in this case, we have a binary. It's linked against libc, and both of them happen to define TLS variables. So the first two entries, real entries in the DTV, they point to the per thread blocks of storage for the executable and for libc. And these are objects that were loaded kind of before main started executing. Yes?
Is it possible that generation and size is different for different threads?
What do you think?
I think it's impossible.
You would be wrong. Concurrency is a thing, right?
You mean at the race condition can be different?
But we'll get to it. It's better. It turns into an optimization opportunity and not just a race condition sometimes. So it gets more fun. So if we DL open something, like in this case a PAM module, then effectively we can grow the DTV by adding another slot, and we can have a pointer that points to another chunk of storage, but it doesn't have to be contiguous with the original storage that we allocated for the binary and libc. So we kind of have two different types of TLS blocks in a thread. We have the TLS blocks that were allocated, we have TLS blocks that are associated with the binaries that were loaded before main, like the immediate dependencies of your library. And these things are always allocated when the thread is created. They're always initialized when the thread is created. And then we have TLS blocks that are loaded after main. We have libraries that are loaded after main, and they're associated TLS blocks. And we can, because of this indirection, actually allocate these lazily on first use. So if you DL open pam_foo.so, if a given thread never actually calls into pam_foo.so, never accesses any TLS variables in pam_foo.so, we don't actually have to allocate storage for it because it doesn't use it.
So this means we do a move check.
Well, that's cheap relative to the expense of what we actually do. So just turns out. So how do we kind of glue all these things together and make it work? So every thread has what you can think of as a logical thread pointer register, or TP, that's usually backed by some kind of actual hardware architectural register. Like on x86, the FS segment is used for 64-bit x86. Sometimes this register has a bias because of the way addressing modes work. So I think MIPS and maybe RISC-V, maybe PowerPC have it biased by some amount because of the way their addressing mode works and to allow them to access a bigger chunk of pointers relative to it. TP, logically, the unbiased version, points to a data structure called the thread control block that's nominally kind of owned by your threading library. The content of the TCB are, generally speaking, opaque to your toolchain for the most part. In particular, your toolchain doesn't really generate code to try to read bits of the TCB in like generated code. Along with the TCB, we also allocate for every thread a chunk of storage called the static TLS block that's right next to the TCB. So you can think of the TCB in the static TLS block as being one contiguous allocation. Okay, and the static TLS block, that was that first category, the ones that hold your executable and all the shared libraries that come along with it. And then the DTV array is some other allocation. It's often its own world. And yes, which allows the runtime loader to move it around and change it. It doesn't affect any of the addresses of things in your static TLS block and so forth. But one thing the runtime loader does have to do is make sure that it can find the DTV when it needs to for the current thread. So what both FreeBSD and Linux and probably many other systems, it might even be de facto mandatory for one of the variants, is that somewhere in the TCB we have a pointer to the DTV. That's not too many confusing acronyms. And then it turns out there are two different ways we can kind of arrange the layout of these objects. So the first one is called variant 1. And so we start off, we have the TP, kind of logical register that points to our TCB. And TCB has a pointer somewhere inside of it that points to the DTV. But in the case of variant 1, the size of this TCB is actually fixed by the ABI. It's defined to be a certain size. And on all the FreeBSD architectures, it may be true always for variant 1, I'm not sure. But at least all the architectures where FreeBSD uses variant 1, this TCB is exactly 2 pointers long. The first pointer points to the DTV. The second pointer is an internal pointer to the thread data structure that the thread library maintains. Because we know that this is a fixed size, we just stick the static TLS block right after it. And in particular, we lay it out so that the binary comes first, and then any libraries kind of come after that, and we can populate the DTV with pointers into this static TLS block that comes right after the TCB. And then, if in the future, if we have mapped a DL open something that has a chunk of storage like PAMFU, its entry is off over here. It's not part of the static TLS block, but still in the picture for completeness. And on FreeBSD, we use this for most architectures, basically non-x86. Of the architectures we still have in the tree. Historical ones, there might be some others that also used variant 2. All right, so the other alternative is called variant 2. It also starts off with TP pointed right at your TCB. And your DTV, so far the pictures all looking the same. Again, the TCB has a pointer to your DTV. But in this case, the TCB is not, the size is not fixed. And usually this is for like legacy compatibility reasons that multiple systems like, I don't know, Sun and somebody else had different sizes of what their TCB would be. So we can't assume it's a fixed value. So we have to do something different. So instead, we glue the static TLS block on the front of the TCB instead of after the back, because we wouldn't know what this gap from here to the static TLS block would be. So instead, we put it kind of right in front. It's pre-printed. We still map our initial things like our binary and our library into this block, but notice we kind of map them in reverse order, which will matter in the future.
But
Yeah.
you have the pointer in the static TLS block. So why?
Just be patient. It'll make sense when we get about 20 more slides. A few more pictures. You'll see, it'll get there. You'll see if I finish my talking time. And this part still looks the same, PAMFU. And we use this on x86 and FreeBSD effectively. So what are the ways that we could get to TLS variables? There's two primary ways that at runtime, as we're executing in a function, we could actually get to TLS variables. The first one, which kind of is called dynamic TLS, is that we can think of the name of a TLS variable as being a tuple of its module index, describing which shared library or executable it came from, and an offset into the per thread block of storage for that module. So a name, like an index and an offset. That tuple is how we will name a variable. And so the way we could compute the address of a variable in that scheme is we use the index as an index into the DTV to get a base address for that block of storage for this thread, and then we can add the offset, and whammo, we've got the address of that particular variable. Now the address of the DTV is intentionally, I think, not directly accessible in the ABI. So the compiler can't directly get to this in generated code. So the only way you can get to this is you have to invoke a function call into the runtime loader to go find your DTV, go crawl inside of it, and find the base address. This is also why you have the chance to do lazy allocation for DL open, because you've got to call a function and it can check all this stuff. It also means we can lazily grow the DTV arrays and all sorts of, which comes back to your generation count not always being the same everywhere. Oh, that was my next point. So got ahead of myself. The other way that we can name TLS variables is for TLS variables that live in the static TLS block, not all of them, but for ones that live in that static TLS block. They were defined in the binary or one of the libraries loaded initially before main. They can be named by their relative offset inside the TLS block, which is going to be some offset relative to TP. So we can skip the indirection through DTV and use an offset relative to TP directly. So for variant 1, we just have to take TP, add that size to the TCB, which is a constant in each architecture's ABI, and then the offset of the variable, and we've got the address where we need to be. For variant 2, you take TP and you subtract the offset. You kind of walk backwards. That's how you find where your variable lives.
Negative offset.
Say what?
Negative offset.
Yes. That's why TLS offsets on x86 are negative.
These two offsets are different.
Well, the absolute value, well, kind of, yes. I mean, it means you have to do a little different math for when I put the offset somewhere, you have to put a different thing, for example, in the God entry for variant 2 versus variant 1. All right. What was my last one? Oh, and then as a result of this, it turns out we can build on top of these to construct 4 different modes for how we can access a TLS variable. And we're going to walk through them in the same order, kind of from most generic and slowest to most specific and not quite as bad. So the first model is called general dynamic. And this model will work for every use case. No matter what, if it lives in something that's DL opened, we can always safely get to a TLS variable no matter what. So the runtime loader for general dynamic has to define a function called underscore TLS get attr. And your compiler emits calls to this function by name. So as part of the ABI, you have to provide it by name. And this function effectively takes that tuple I described, the module index and the offset, as arguments, and it returns a pointer to, for your given the current thread, a pointer to the storage for that symbol. Then part of the way we implement this is every time you have a TLS access inside a given library, we allocate a pair of God entries. And one of the God entries holds the module index, and the other God entry holds the offset. Which means that these God entries require dynamic relocations, that the runtime loader is responsible for populating these God entries when it's resolving relocations, when it loads whatever library or binary contains the God entries, to have the right index of the TLS variable. Once it's decided where that TLS variable storage lives, like which library it comes from, which might not be the one that's accessing it. So the God entries live in whoever's doing the access. The index and the offset are whoever defined the storage and location for this symbol, following normal symbol resolution rules. So every time we want to access the variable, the compiler emits code to call TLS get attr to get the variable's address. And within a given function, the compiler, it is safe to know it's not like you magically change threads within a function, so it can cache during a function if you do multiple accesses to the variable, which is a little bit better than errno, right? But in general, this model looks pretty similar to error, but it's all done by the tool chain. It doesn't require you to write all this bespoke code to pull it off. But that's kind of the level of efficiency we're talking about. So let's look at an example of this in code. So I have a little sample program. We throw it into Compiler Explorer and compiled it in this particular this compiler with this configuration. We have a thread local variable, but it's not defined inside the code we're running. Like if pick, presumably this is inside a shared library, and so X may live somewhere else. We don't, at least in the object file, we don't know if it lives in our same library or not, and we're just going to return the value of X. So the one thing you might notice that's kind of odd is we load a single register as the argument before we call TLS get attr. And TLS get attr returns the pointer, and then we can use the pointer to read the value and return it. But I mentioned that we kind of pass two things to TLS get attr. It's in theory like a tuple of an index and the offset, but we only pass one register. The reason is that what actually happens under the hood is we have effectively we pass a pointer to a struct that has the two things defined, which means we are passing a pointer to the first God entry, and you actually get the pair of God entries as a nice little struct that has the two things on everything but IA64, which we don't care about. I'm not making it up. So the next version is something called local dynamic. And you can think of local dynamic as a kind of optimized version of general dynamic that we can use if we know that the variables that we are accessing are in the same module as the function doing the access. For example, if the variables are static, or even if they're not static, but they're marked protected, meaning they can't be preempted no matter what, then we can potentially use local dynamic instead. The way that local dynamic works is instead of having a pair of God entries for every variable, we have a special pair of God entries where the first one is still the module index, just like in general dynamic, but the second God entry is hard-coded to 0. We don't even emit a dynamic relocation for it. And you still call TLS get attr the same way you would to access any other TLS variable, but the thing you get back is effectively a pointer to the entire storage for like my current shared module, or my current shared library. And then I know by static link time at least what the offset of each of those variables are within my shared library. So I can add that relative offset to the base address for my block. And in particular, I only have to call TLS get attr once inside my function, and I can reuse that base address multiple times if I'm accessing multiple variables. But it turns out it's not really all that useful. You're still calling TLS get adder. If you only have one TLS variable, it's basically just as expensive as if you use general dynamic. So lots of times it's not useful. Also, for other reasons, as it turns out, in common cases, it doesn't get used very often. So what does that look like? So in this case, in my example, I have two TLS variables, x and y, because I want to do two things to show off that. They're marked static. That means that they're going to be defined inside my same library as my function, so I don't have to worry about them being preempted. And we get a bit of different code, right? So we still load a pointer and call TLS get adder. If you stared like in detail at this compared to the other slide, the name of the static relocation is slightly different. This is referencing this kind of special God entry where the second offset is 0. And then once we have them, let's see, where are my bubbles? All right, yep. So we have one call to TLS get adder instead of two with a special pair of God entries. And then these kind of offsets, immediate offsets to the load from the base pointer in RAX that came from the call to TLS get adder, these get resolved to a static constant by your static linker like LLD. The at DPT, whatever, that's effectively a special type of static relocation that tells the static linker how to do the fix-up. But effectively, this means what is the offset of x in the TLS block for my library? What is the offset of y in the TLS block for my library? All right. So that's 2 models down. We have 2 more to go. And what is my time? I don't know what time is.
It's down to 2.
OK, and when am I supposed to be done? OK, good. Yeah, well, good luck. We'll see how this goes. All right, 2 more models to go. So the next one is called initial exec. It should be like static something, but it's not because just the names are. An initial exec, unlike the dynamic models, we're going to use the static TLS mode to access variables. So we're going to be using offsets relative to TP to find our static TLS block and access things. It's only suitable for accessing TLS variables that the toolchain knows somehow are defined in either the binary or the set of libraries that will be loaded before main runs. Kind of that first set of things that live in the static TLS block. So in order to use this, you have to have some way of knowing, either because you're the executable or some other kind of hint that it's, that it's going to be safe because this variable is definitely going to live inside your static TLS block. So for example, accesses by the executable, always. Because the executable can't link with an undefined symbol. It also can't load at runtime with an undefined symbol, like RTLD will be unhappy. So no matter what, if an executable is going to access a TLS variable, it's always going to be in that static TLS block one way or another, even if it's defined in a library like libc. But also, if you have libraries that you know are never DL opened, that they're always going to be loaded along with a binary, either by fiat or because it's just always true, you can also use this mode for those types of libraries. And in particular, in FreeBSD, we turned this on with compiler flag for libc and libsys, because you can't really DL open libc. You can't really have some of the C startup code is in libc. You just can't have a binary without libc and FreeBSD, unless you're Rust and you do terrible things or something, or whichever one it is, Go or somebody. So in this model, instead of having a pair of God entries with an index and an offset, we have a single God entry. And it also contains an offset, but it's an offset within the static TLS block. So every time we want to access a variable, what we do is we go to our GOT, we read that offset out of the GOT, and then we can add that to TP with the right formula to figure out what the address of a TLS variable is. So here's an example of that on x86. In this case, we're back to kind of our original example of, the X might be defined somewhere else, but we know it's going to be OK. It's all going to be safe, I promise, because I've told the compiler, thou shalt be safe. This is what we do with libc and libsys, for example. In this case, the compiled code is a little different. We have a single static relocation, and we're going to do we have an offset in the GOT, my bad. So we have one dynamic relocation for this God entry. We read the God entry that gives me the offset of my variable into REX. And then we use that as the offset to FS, which is effectively TP on x86. And remember, in the general dynamic models, we never saw FS or local dynamic. We were calling TLS get adder, and that's behind the scenes. That function effectively uses FS to find where you are, but here the compiler uses FS directly. And then the last model is called local exec. And local exec is an optimization to initial exec, kind of similar to the way that local dynamic is an optimized version of general dynamic. And in particular, we can use this when we know that the variable being accessed is defined in the executable and being accessed from the executable. In particular, I mentioned earlier that we were intentional about putting the PTTLS block as the first one or the closest one to TP. So we know that effectively it has a relative offset of 0. It's either, like it's the offset of that block always starts at either TP plus the size of the TCB for variant 1, or it starts at kind of 0 walking backwards for variant 2. So in particular, this means that in the static linker, for any given variable, we can figure out exactly what its offset is as a constant. And we can fix up the instruction with that constant and not have to read anything out of a GOT entry at all. So no GOT entry, no dynamic relocation. And in practice, this is also what static binaries end up doing, because in static binaries, all this crap collapses down. And because we don't do DL open from static binaries, because we're not that nuts yet. So if we do local exec on x86, so here I've got it static. I've told it I'm compiling an executable by claiming I'm doing pi. Then in practice, now what we get is we have a truly static relocation for what is the offset of x inside of the executable, and we can just apply that to FS directly. We have no indirection. We don't need to read any extra variables. We just get straight to the address. All right. So the next little topic is something called linker relaxations. I talked about this a bit briefly, I think, last year in Euro, but this is also applies specifically to TLS. So in general, inside the linker, sometimes when you're processing a relocation, if you have special knowledge, you can sometimes take a slower or more general approach to some instruction sequence or operation you're trying to do and replace it with a simpler one, maybe one with less memory accesses, potentially fewer instructions, or faster in some way. You may have had it with NOPs or other stuff, but a way that you can do it faster. And when this occurs, the linker is effectively relaxing the requirements on that access. We have some knowledge that tells us we don't have to do the general purpose thing. We have some reason to know that we can take a shortcut. And so we call them relaxations because we are relaxing these requirements. And for TLS, there are several of these that you can do, in particular when linking executables. Because remember, executables, any variable you're going to access is going to live in that static TLS block no matter what, regardless of how your object files were compiled. Even if your object files were compiled in such a way that they were using, for example, general dynamic. It's always safe to collapse to some form of static offset, or static access. So in particular, if while you're linking the executable, you find that you have a general dynamic access to a TLS variable, if you find that that TLS variable is not preemptible at all, it's defined in your executable, then you can relax and replace a set of instructions that passes the pointer to the GOT entry, and even the existence of the GOT entries and the dynamic relocations for that. You could take the instructions that called TLS get adder and the pointer to the GOT entry, and you can replace them with the last thing I showed on the slide, just a simple straight move. Because you actually can compute what that offset is because the variable is non-preemptible, it's defined in your executable. If, on the other hand, the symbol you're accessing isn't defined in your executable, it's in one of your shared libraries, then you don't know a complete static offset, but you know it's still going to be your static TLS block. So you can also relax those all the way down to initial exec, where you have a single GOT entry with just an offset relative to TP. You can also always relax local dynamic if you happen to encounter it down to local exec. The reason being that local dynamic is only safe at compile time if the variables are not preemptible. So that basically collapses back down to this first case, and it's effectively like doing GD to LE. And then lastly, if you have code that was compiled kind of like my 2 examples ago as initial exec, and it turns out at link time, you were accessing a variable that's defined in some other .o file, and it happens to be a .o file in your executable, which you find at a link time, then you can replace that IE access with a local exec. Yes?
What is preemptible in this context?
So in ELF, preemptible means that ELF has a rule for how it, this was actually, like, I think, in last year's talk. ELF has a rule for how we decide when you get a symbol name, which symbol do we use? Because you can have, like LD preload depends on the fact that that library in the kind of graph that you build of dependencies comes right after the binary and before any libraries you depend on. So for example, if you LD preload something, it's kind of below the binary but right before libc, which is why you can override symbols in libc, because we walk down to find it. Well, a symbol is preemptible if it's not defined in the binary, so it's eligible to find a definition in something else. It's non-preemptible if we're always going to hit the binary first, and we're going to find it no matter what. So one upshot of many of these approaches is we have more relocations, more dynamic relocations in particular. I'm not even counting all the static relocations, of which there are legion. But all these God entries that we described for everything but local exec, they have to be populated somehow. So usually these are handled by dynamic relocations and your runtime loader. For example, the module indices are always unknown because that's a number the runtime loader makes up. Well, not quite makes up, but they have to be 0 to n. But it's a number that the runtime loader comes up with at runtime based on the order in which it loads the objects. In a few cases, you can actually store constant entries as the linker usually, maybe the compiler, in your GOT and avoid having relocations at all. So for example, with local dynamic, the pair of entries has a hard-coded offset of 0, so you don't need a relocation for that. It's just going to be 0. Another approach you can do is if for some reason maybe you don't support rewriting the instructions for relaxing IE to LE for a given architecture, you can still do something kind of cheap in that you can compute what the offset is going to be for a variable defined in the executable and write that into the God entry that the executable will use to access. So at least you're not having to fix it up at runtime. It's still a static constant. All right, how am I on time? So I didn't even think I would get to this slide, so I don't really have time. I'm going to blow through this. This is for you to read because this is another 20 slides. So this is just for your own suffering. No, you've had enough. So linker relaxations have some restrictions in that we can only do them at static link time. In particular, library, you can only do relaxations for a library if you know for certain that it's never going to be a DL opened, like libc and libsys. But lots of libraries are de facto never DL opened. Most of the libraries in your, depending on your process, but in many processes, a lot of your libraries are not DL opened. And so they are always going to have their variables happen to live in static TLS, or at least within a single process they are. But because we don't know for certain that they're in a static TLS block, all the accesses inside those libraries still go through general dynamic, the slowest possible path. So you can think of TLS descriptors as a kind of way at runtime we can sort of do something like linker relaxations on the fly by having something that's a bit cheaper than TLS get adder in some cases. So what we do with TLS descriptors is instead of hard coding a call to TLS get adder, we take those two God entries, the module index and the offset, and we replace them with two pointers. The first pointer is a function pointer that the runtime loader sets, and the second one is an argument, a single argument passed to that function. And so in certain cases, the runtime loader can use optimized routines, often written in assembly, to avoid the kind of slow path of TLS get adder. So for example, if a variable, is it my point here? Yeah. If a target variable actually lives in the static TLS block, that's where its definition is, and you're going to access from the given shared library, you can use as a function pointer, you can use as an argument to the function pointer in the second God entry, the offset inside the static TLS block, kind of as if you were doing local exec. And the function pointer can be this very small little function written in assembly that only does, uses TP with that offset to compute the address and return it right away. And the other thing that happens to make this even more optimized is with TLS descriptors, the ABI is a bit weird. They'll go out of their way to avoid having to save and restore as many registers, or they'll pass things by register instead of by function for i386, for example, to try to make this as cheap as possible to call compared to TLS get adder, where you have to treat it like you're calling an arbitrary C function and throw away all your non-call safe registers and things like that. That's all I wanted to say about that. It's way more complex. And there's like a bazillion relaxations for this as well, of when you can relax between these different things. All right, last slide. So places you can read more. Many years ago, Ulrich Drepper wrote a white paper describing much of this that you can read. It's kind of the canonical thing, I think, for many folks who want to learn about how depressing this is. It does not cover TLS descriptors. That's an innovation that postdates Drepper. Compiler Explorer, as always, is a useful tool. And Masqueray, one of the LLVM developers, he has a blog that has a lot of good stuff about this. In particular, he has a blog post that's just about TLS that he updates. And he talks in more depth about TLS descriptors and things like that there. And with that, I think I may have negative time for questions.
Maybe a bit tangential, but when you were talking about PT-TLS segments in the beginning, it reminded me a lot of what we do for DP, CPU, and VNet.
Yes, except that we do it horrible and terrible in the kernel.
So I was wondering, is it possible to re-implement mechanism and to re-implement this stuff? It's kind of complicated because like the runtime gets to define what a thread is, but
yes.
Different, like the per CPU, per VNet stuff. I don't know how you distinguish between those because you just go through TLS get adder in the worst case. And I don't know how to.
So I think that the trick is that the thing that gets really suffering is, or that makes VNet and DPCPU really terrible, is the way we do the actual memory access. Oh, please repeat the question. So Mark asked, hey, all that PT-TLS stuff sounded kind of neat, and we have these terrible things in the kernel where we also want to do what are not per thread allocation blocks, but either per CPU kind of symbols in effect, or per VNet symbols for VNets. And we do a really hacky thing where we do define kind of custom ELF sections that function kind of similar to the way TData works, that define the initial contents and initial template that we use to copy into each vimage. But the thing that's terrible is when we actually do the memory access. We abuse something, we effectively have to treat the symbol, like an address of the symbol, as the offset, sort of. So we, in the kernel runtime linker, we know these are special symbols, and anytime we find a relocation that references these symbol names, we convert that symbol name and the use of that symbol name not into the address inside the template, but as the relative offset inside the block. So that we can kind of do something TLS-y-like. It's hard to, I don't know that we could honestly, not enough of the stuff in here is abstracted enough. If you wanted to have this apply to something that's not TLS, unfortunately, you would have to probably define yet another set of chunk of relocations and things. And I don't know that that's maintainable upstream. Like, there's not I can't think of a good way to abstract it that we have kind of an arbitrary address space is kind of what it is. Maybe there's something, but even I think the address space support that like GCC and Clang have isn't really well supported for even this. So I'm not aware of anything in the toolchain that would make us, give us the ability to do that less terrible than we do today. But you're right, it is kind of a similar-ish problem.
The shape of what you're talking about is immediately reminiscent.
Yes, no, because it is, yeah. Any other questions? Go ahead.
So we talked about allocation and access, but I'm curious about the cleanup case. Like if I DL close, is there some sort of DTV reclamation scheme you have, or how does that, can you give us an idea of how that works?
I may not have a good answer to your question. So it is true that, no, it probably does suck.
So it's next year's talk.
No, I'm trying to be done with linker talks until I talk about cherry linker stuff. So we definitely have the generation count, which we do. So every time you call TLS get adder, we will grow. I don't know if we ever shrink the count. Maybe we do. We might. Because anytime the generation count is different, we reallocate to whatever the current size that's associated with that generation count is. So it may be that we actually shrink. But I would need to check to see if we bump the generation on DL close. But of course, part of the problem is how do you free all the things? So the thing that would seem consistent in this model is if you were to do that, as part of shrinking, you would want to, at that point in time when TLS get adder is called, actually probably go free the darn things. You probably don't want to try to, like, there's no stop the world. We don't have a good way of, like, enumerating all the threads to free them. And what I remember in that code is I think I only saw us allocating things lazily on demand if we were accessing a slot that was null. I don't think I saw us really being safe to shrink So my guess is we probably don't shrink. It probably stays there until either the thread exits or the process goes away.
Because there are programs against better judgment.
That they can DL open and DL close a whole bunch?
Close and everything will be taken care of.
Yeah, I mean, it is fixable with just, that's actually not that much more code to write, probably. It would basically be, if we don't do it already, bumping the generation count every time we do a DL close that is affected, and making sure we handle shrinking the array sanely. That, in theory, would work. Oh boy, but then what happens if you miss a race? See, this is terrible. So, well, what if your race is a DL closed, a DL opened, so I'm now reusing the module index for something that DL opened, and the thread in the meanwhile has never called TLS get adder. And then it calls TLS get adder. And it says, oh, I'm going to change the array to match the new size because the generation count is different. Oh, it's the same size. I'll have to realloc.
You would need to check the generation and remember which generations removed things.
Yeah, it turns into nuts because what you need is you need, at that point, a generation count per DTV slot, in effect. And we definitely do not do that. So that may be why we currently don't. I bet we don't do it for that reason. Which means we probably don't even allow you to reuse module indices. If you keep doing this, we'll just keep growing the DTV forever. Yeah, the sad face is the appropriate response. Yeah.
Yeah, is there any technical obstacle of having variant 2 everywhere that is putting the static block before the TCB, even in variant 1? Because I contend you cannot do it in, you cannot put the static block after the TCB if you don't know its size, but would it be possible to put it
Well,
every time?
if you want to go rewrite all the compilers and tool chains to do it, then you could do
I
it.
understand that part, but is there a technical obstacle to that? No,
I mean, changing the ABI mid-flight on the architecture at this point of a given architecture is probably undoable. It seems hard to imagine why that's worth the gain. I think also the assumption was that variant 1 is generally cleaner if you can use it. Variant 2 is around for the architectures that are the bad children where we can't use it, is more the way to think of it.
Yeah, Robert Watson would call it a very brave plan.
Ambitious, I think, is the British word you want to use. Ambitious. All right. Thank you all.
You know all this. But having the team here is awesome. Are we still a minute? Oh, we're on the dime? Okay. Welcome, everyone. My name is Michael Dexter, and I'll be talking about community event organizing. I have about 40 minutes, and I can't teach you everything, but I can inspire you. So hopefully you'll come away with something useful. And is everyone comfortable? Yes? No? Maybe? Been a good event? Any special requests insofar as like you're working on an event and you have some idea, and if anything, start thinking about it. I'm totally cool with questions during it. I'll have some moments for questions. So I'm relatively easy to find. I'm on the Fediverse. That's been a lovely platform that went from a few Tedu posts per day to hundreds per day, which is now frustrating insofar as there's so much content, so many great people answering questions. The Fediverse rocks. You can email me. You're welcome to editor@callfortesting.org. Note that editor doesn't step on any toes in marketing departments or engineering departments. It's just out there like senior analyst, just far, far away. Works great. And there are YouTube videos of mostly call recordings from weekly calls. I'll touch on those. Thank you for everyone in the room who's been on those. So by day, I offer open source training and storage support, and I moderate the aforementioned calls, and I'm very busy in the Latvian American community with my wife. Show of hands, who can recognize this little fella? Check out Flow Movie, made with Blender in Latvia, and won both the Golden Globe and the Oscar for the win. Normally, I'm talking about jails and zones, OpenZFS, Beehive, a little ARM64. You can track all that at callfortesting.org. And I've given a conference talk or two. I do not know how many. As for events, I've organized 10 Beehive cons at events like this, 3 OpenZFS summits, about 350 production user calls based on a quick count on the YouTube stats, 3 BSDCans for fundraising. I'm glad we're all here to talk because without that, I guess we wouldn't be here to talk. I do also the swag, we'll get to that. And about 150 Portland Linux Unix groups, including Linus Torvalds as a guest, who doesn't show up at most events. So it's a key to know how to talk to people like that. And I've done lots of Latvian events, be it Independence Day, be it concerts like Shipsy. Anyone? Shipsy? Latvia's Taylor Swift? Anyone? So, in doing about 200 plus events, I have literally no idea how many, in 7 countries of all sizes, cadences, you name it, I don't consider myself an event organizer, despite all that, because I just organize events, because I consider them an integral part of this open collaboration we all do for operating systems, for file systems, for you name it. It's just part of it. It's just like committing code. It's just you meet. It's important. So very briefly, what's an event? Especially post-COVID lockdown, because a lot changed. So fine, 2 or more people synchronizing to discuss shared interests within the confines of languages and time zones. And I emphasize that because we're here in English, not French. We are in Eastern time. Some are watching the stream. Some are up really early. Some are up really late. And thanks to all that time we spent on Zoom, Jitsi, and other platforms, we are down to languages and time zones. I call up Melbourne all the time. I call up Yerevan all the time because we're all comfortable and have this fluency with just talking remotely. So the synchronizing is important. We have a topic. OK, fine. BSD Unix, cool. We're in the same time and place. We've agreed on a language to go with. And welcome to BSDCan, because it's pulling that off as we speak. And as Alan Jude put it, didn't know you'd be here. I hope I quoted you accurately. You come to recharge your BSD batteries. Some of it's just the hallway track. It's the interactions. It's the recruitment. It's a lot of things that often can't be discussed over the wire. So welcome. It rocks, and we all do this for various reasons. So we've got a time and a place and a topic. And fundamentally, and one book described it as like, well, the second to oldest profession is bringing people together to talk, which arguably could be the first, but there is zero fundamental cost to meeting up. Just put it out there with all these free online tools. You just say, hey, we're meeting up at the cafe to discuss BSD Unix in your town, key point, your town, and we're not here to fundraise for a big event because money is complex, and I'll get into that. But in Portland, Oregon, there's BSD Pizza, resurrected from the good old days with Rod Grimes and company back in the 90s, I suppose. It's been going on. There's a domain name. They announce on Calendar, the calendar aggregator, and say, hey, we're meeting up at this pizza place this month. And that's their big old investment in that very durable event. And for super durable, there's Plug, the Portland Linux Unix group. It's been around since like 94, maybe 96. There is a mailing list in addition to a website hosted by OSL. That's like $20 a year for the domain. The hosting is donated, and it's been around for decades, 30 years plus, and it's very durable. I think people will show up first Thursday after the apocalypse like cockroaches. Just it's what they do. It's awesome. So simple is sustainable. Everyone, please get that in your head. It is arguably infinitely sustainable. If you don't just dive head first all the way in and spend a bunch of money and risk a bunch of things, simple is pleasant. I miss simple. So is it just scaling from there? Like money enters a picture and you work your way up and have bigger events, bigger, bigger, bigger? Okay, sorta. But it's not just number of attendees or dollars spent or any of that. I think I have a different metric. And you know, that library room might be free. I hope I'm synchronized here. The pub with a space to meet, looking at the nice buggers in the room. It's like, yeah, we buy drinks, they provide space, and oh, 2 of them at least. And then, wow, do we go to the convention center in Ottawa and spend all this money and have all these Teamsters and all that stuff? Well, I don't think there's like a linear scale there. All those numbers, raw speeds and feeds of an event, are not the metric. The metric is comfort and comfort zones. And I will illustrate what that means. For example, like, what country would we like to visit? Obviously, Canada. Yes, you've come to Canada. That's cool. If we were a little further north, we've got Arctic BSDCan in Canada just north of here. I know some OpenBSD folks who would be totally down with that. They'd be like, yes, we'll have satellite internet, we will do whatever, and they'll rock it. We could also do it in Ottawa. But it kind of matters what time of year we do it in Ottawa, because it gets kind of chilly here. So you got to take that into consideration. We could also take into consideration the fact that, looking at you, Peter, Canada was important for export controls and crypto development, so it was great to meet in Canada. And that was a cool flex of this organization. Fast forward to now, it's like, oh gosh, yeah, let's not meet in the US. Canada sounds really good. And large sponsors from this event are like, so tell us more about organizing in Canada. Let's discuss that. So suddenly, it's a hot topic. So if it's not Canada, how about Kyiv? We could have Kyiv BSD. That'd be awesome. Great event. That was 2009. Or Kyiv BSD. Maybe not. Maybe not. Armenia. Maybe we bring a smaller crew to them. I talk to Armenia every week. I mean, great place. Got your Ararat with brandy and all the things. We could go south of here. I'm not getting much feedback there. PDX BSDCan. I've had the domain for years just as a running joke about, now can we do Euro in Portland? They didn't like that idea. So it's what are you comfortable with? Because it can be Ottawa, but in winter, not so much. What about the space? We could have like Vegas. Who likes Vegas? Show of hands, who loves going to big old trade shows in Vegas with booths and miserable booth staff? Not one hand. Wait, what about nudist BSDCan? Comfort zones, anyone? Any takers, any takers? So geek cruises were a big thing back in the 90s. You may recall those, like Pearl Cruise and all the things. Ignore the contagious diseases. But that was a cool idea. You know, they synchronized with a cruise line and did the thing. Do we have a BSD cruise? Maybe. The spa. Yes, we could have a conference at, let's just call it the storage pool allocator with massages and other things after sitting in these chairs for 4 days. So Pajama Day, big old conference centers, technical colleges. Bellingham Technical University hosts Linux Fest Northwest. It is the most beautiful combination of a school partnering with an event. When they built a new building, they put outlets in the floor to match tables. It was just like brilliant. It's one of the oldest Linux Fests in the world. You could do it at like Latvian centers. There's one in Ottawa and Melbourne and Seattle and true story there. Your local church, fine. Yes, get creative, please. And about the whole comfort zones thing, where are you comfortable opening up and discussing these topics? We have shy people in our community. We have people who are uncomfortable opening up. So along those lines, the organizer, looking at two beloved organizers in the room, our comfort zones are pretty important too. And it's often behind the scenes and it's often hidden, but okay, you organize an online call. Are you comfortable turning on your video? Some aren't. That's cool. I'm cool with that. Are you comfortable standing up at a podium like Pat did and say, hey, welcome everyone? I could not have done that long ago. Even in my 20s, I was terrified, believe it or not. Are you comfortable talking to your boss at your cool company about sponsoring an event like this? Anyone at a cool router company, networking, you name it. So just an introduction is all we ask. So are you comfortable talking to a restaurant manager saying, hey, you've got this room, what are the terms? Like how much do we have to spend? When's it available? Blah, 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 blah. Going up to the second floor and asking the manager is terrifying for some, and I get it. That was me, I get it, I get it, I get it. Are you comfortable waiting with unreliable restaurant managers who don't quite get back to you? And it's like, well, we've set a date and we've announced it, and like they're not really getting back. Are you comfortable fronting some money? Just like, oh, this pizza, we want it ready when they get here. Hopefully they'll pay back. And it's, a little small investment. Or a little bigger, we promoted it some. We had to pay the restaurant like $100, so about $250. Hopefully people chip in kind of thing. And are you willing to put a big old event with loyal sponsors, loyal attendees through a personal account? Some are not comfortable with that, and I agree completely. What about your own business account? I don't know, a bunch of us have independent little business accounts. Are we comfortable with that? Maybe, it's been done. Are you comfortable putting down a 10 grand deposit on a university and spaces and room blocks and catering blocks and all that? That's terrifying. And thank you, anyone in the room who's participated in that. Melissa, you rock. But some people will say 10 grand, that's the smallest deposit we've ever paid. So it's all relative. From turning on that Zoom camera to that big old deposit at a university, it's all relative. So to that end, establish your comfort zones for everyone involved early. You've probably been to corporate events where it's super slick, but it doesn't match the community. And they're all kind of uncomfortable, but it's like super in your face, or vice versa. You have to have everyone on the same page as best you can, or they won't come to your talk, et cetera, et cetera. So any questions at this point? Any goals for people who want to host events? Because I can probably chip in something. Anything yet? Okay. So question for ya. What is the single greatest challenge in event planning? Number one. Anyone?
Getting people to show up.
Getting to show up, yep. Okay, people to show up. You're here, you beautiful people. Venues. Venues are the problem. It's not the money. It's not the, you can have risks. Venues are a flipping nightmare, and that's based on a decade or two of this. So, okay, they are intertwined with your comfort zone. I mean, there might be a great meeting room at a penitentiary. Some folks might not be comfortable with that, and all those examples I gave earlier. So moving on, the whole balance of price, location, accessibility, amenities gets kind of crazy. And a key thing there is please, 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 please recognize a priceless venue. If your boss lets you come in on a Thursday after hours for a few years straight and chips in for some food and all that, thank them and don't take them for granted, because that kind of thing is absolutely priceless. Until once you lose it, you realize, holy hell, it is hard to find a place that meets criteria. Let's talk criteria. The ultimate small venue. You're in your town, wherever that happens to be. Well, we want maybe a restaurant with a room. Fine, cool, yeah. It's easy to get to by bus, because a lot of people come from school or work and whatever. They make it their way there, or they need to park. Parking can be a problem. Oh, do we have an okay projector? And can we hear? And can we see the people with some decent lighting? And, well, is it okay just to buy some food and they're cool with that and let us use the room? Or do they want some money for the room? Da, 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 da. Is it quiet enough to hear each other? I'll get to that in a second one. Libraries don't have food. They probably don't allow it. So, you know, after work, you probably want a pizza, beer, maybe something else, some sushi, I don't know. So bars make money on loud things. Trivia night, that's a new thing they do. And he shoots, he scores. Ah, you've heard that all week here. So having your meeting next to that, yeah, it kind of sucks. Offices are often limited to business hours. You've got the pressure of, you know, well, you know, the person is, you know, on overtime to be here, and we do love what you're doing with your Unixy thing, but so it's tricky, and it's like, oh, well, we could do it at the house, and your spouse is like, what? No, how about not? You know, kids have to have that project tomorrow, and blah, 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 blah. So working up from the impossible, let's go to the next level of really challenging. You start getting serious about AV. You know, it might be built in rather than just lugging the projector and da-da-da-da-da. Networking, hopefully you can stream it to everyone at home or around the world. Catered food. I just saw a venue where there's a kitchen next to the presentation area, and it's like, great for a cooking show, but we're not doing that. So they set up lunch during a presentation, and you get overload, over whatever, overspill of sound. It's like, no. Parking, transportation, and prices start going up. So like, yeah, we have a great room, it's $2,000 a day. And it's like, well, but we're just a bunch of volunteers working on file systems and stuff. So that's tricky in the medium. And then you want a BSDCan. I mean, hats off to Euro, who has a different country. Every year, you want good airline connections. That can be a challenge. Ottawa is number 6 in Canadian connectivity. Cool. And this week was pretty rough for a lot of people, thanks to, was it World Cup? And yeah. Public transportation, pretty good around here. That's cool, that's cool. Affordable and mid-scale housing. If you've been to a conference in Silicon Valley, you've got like the San Jose or San wherever convention center with the attached hotel and a lot of money per night. And if you're, say, offering housing to speakers and participants in various ways, and students, key point, that $350 US per night is not sustainable. And of course, food, you know, if you have the same conference food every day, you want a different dinner every day. That's kind of implied. And, you know, walkable, which this venue is great about walkability. Hats off for the market, etc. Moving on. Oh, 200 to 400 people, pulling it off. Great. Smaller halls. And thank you for pointing this out this week. Having one big hall is pretty common. Having classrooms, which are different from what you see as breakout rooms at a hotel or at a convention center or just about anywhere else, any office, that's a school thing. So suddenly you're slammed into the school scope. So comfortable and quiet seats. I noticed the second to last row is still squeaking as I get a demo from Patrick on squeaky chairs. And yes, we all know the third row has dead power across the entire way. And okay, fine. And then maybe more so than a class, we have a lot of question answer and dialogue, and we'd really like to encourage that. Apparently they have built-in mics that are super sensitive that they use for that, but that leads to other surprises. So push to talk is awesome. You just kind of do the United Nations thing, and when it comes time to talk, the light, that's great, and maybe we can incorporate it here, but we can aspire to things. Wi-Fi and Ethernet. It's like, well, the streaming is very latency sensitive. Wi-Fi with 200 to 400 people is all over the map. So you truly need a venue that says, oh, more than we have Wi-Fi. Everyone has Wi-Fi. That doesn't mean they have Wi-Fi for this. Good airflow for health. You know, I've been at venues where it's like a tornado, and that's a good thing. That's a very good thing. And breakout spaces. We've been doing a room nearby that's awesome. Upstairs is great, and some people just have a 20-minute Zoom call or whatever call they have to do and disappear for that. Naturally, you want a catering space. It's been working great here, out there, and it's very social and easy, and you can run back if you forgot something, and da-da-da. Wow, but if you're confined with schools, they're often like, oh, right, we've got this meeting that needs to take up these 2 classrooms. Like, well, hold on, we have a schedule using those 2 classrooms, and that. And reasonable prices, which is universally a challenge anywhere on the planet, and funny, they go up, not down. Shopping for missing things, oh, my laptop blew up. Go to Future Shop or whatever you do in Canada, or local recyclers for X220s for the 30s or 70s for the AV team, whatever old clunkers. I hope you don't need flash storage because that's, yeah, bad. And tourist destinations. If you're gonna haul over there and you want your spouse, your partner, your kids, your +1 of any form, it's good to have some options. If you're at that penitentiary, hypothetically, yeah, no, they're like, nope. So yeah, it's tricky, and it's a tall order. And who are your greatest assets? Allies, professors. Herr Reuschling, professor at a university. I trust you've organized a few rooms for some local folks because that's invaluable. In a student group, oh yeah, we have a BSD club. Yes, please. And they'll gladly, you know, maybe even for credit, donate their time to hold signs, to direct people to whatever. Linux Fest Northwest does that beautifully with the technical college. So early on, get those allies, maintain them. Students often have a 4-year cycle, and you lose them as soon as they're getting good, et cetera, et cetera. And any venue can have surprises. Fukushima, yes, sinkholes around the corner, alarms during the keynotes and stuff. Remodels where like, oh, no, it's fine, we just moved you to another space. Like, well, hold on, how far away, et cetera, et cetera. Of course, broadly, lockdown was a big inconvenience. But every organization you talk to responds very differently to the inconveniences, and they're inconsistent. Like, hey, they tell you everything and spell it out, or they surprise you. I'll put it real politely. So let's just say you have a great venue, despite it being a really tall order once you think it through, and you might have a theme like BSD Unix, but pick a format. Yeah, you can do the old BSDCan format we've had for decades, which is good. Cool, great, yes, but please think of new stuff. And I was really impressed with the vendor summits and such. The foundation organizes them. The November ones have been great for 3 years running. They have a great venue that's free of charge. I hope they appreciate it. It's awesome, it is great. But go with themes, virtualization. BeehiveCon is technically that. Documentation. Documentation is really important. We all kind of agree, but a lot of people agree not to do it because they're like, yes, I did the allocator and you can document it. Hackathons, those have been plentiful for a very long time. Embedded hackathons, hypervisor hackathons, storage hackathons, anything, you name it. I don't know, I don't care. Underrepresented groups. This has been one of the most diverse events I've seen in a while. Good work. As a colleague also organizing out of, back in the OSCON days, pointed out, wait, when you say online event, you mean different time zones all synchronized together. I'm like, oh, okay, why not? Introduced to BSD, introduced to ZFS, introduced to something, I don't care. Something for only new users. We've got some engineers here who were at the Berkeley project back at Berkeley. So that's not for everyone. They're amazing, they'll answer any question, but what about strictly for new people? Roller, you've done some great local things around the world, good work. There's a template to go with. Shy BSDCon, there's so many shy people. Like, what is it that would make people the most comfortable? Focus on kids, BSD for kids. I don't know. Be creative, please, please, please. And unconferences. Meet BSD started out as an unconference. It was like, well, let's get the big old pen board and vote on topics and come up with topics. And one of them was virtualization. And people ignored the other rooms, got in a big circle, and we discussed where we're at with virtualization back in 2010. It was a 2-day event. There was a smaller group meeting up in a little awkward, cramped room. And a year later, out popped Beehive, the hypervisor for FreeBSD. It takes those discussions, it does. One-to-many monologues have their place, but when it's that kind of genuinely move the architectures forward, you gotta do that. So please, something new, something we've never heard of in your town, wherever it is, just be creative. So you've got all that. And you've got a mild time of year when it's not like Ottawa with snow and yeah. Dates and deadlines, just a little quick bit about this, because some of this you see, some of it you don't see because it's internal. Like, when should we do it? The announcement period is typically about 2 months minimum for some small event. Some are a solid 9 months ahead. Ideally, we announce the next one of these at the closing ceremony session, but that can be tricky. We're not quite there, are we? It is great to be adjacent to a big event, a day before or a month or two before. Because often talking to the Alan Judes of the world, it's like, yeah, I'll be in San Jose, but not twice in 1 month. Please collapse those, and sure, happy to. And that applies to many, but I've definitely heard that feedback from you. It's like, yeah, not helpful. I don't really want to go there twice in 1 month. I announce my calls like a day or two before, and people show up like clockwork, just cron job, fine. Pizza, it's about 2 weeks, fine. It's like, hey, here's the current, this month's place is this. So the time is the same, but it's a different location. A BSD day, fine. 2 to 3 months. Sometimes the longer the announcement is almost a penalty. But of course, a giant BSDCon, you want long announcement times and travel times and visa applications and letters of permission from the blah, 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 blah. Avoid holidays. I guess we're slightly stepping on Father's Day. That's fine. We dads are like that, looking at the dads around the room. Victoria Day, marathons. Flights might be half as much because it's a really unattractive time on Christmas Day, or they might be twice as much on spring break. Are there stores closed on Sunday in Germany? Are there any Germans I can pick on? I'm going to pick on a German. It's like you show up and you're a tourist and you're like, I can't eat. So when it comes to bringing the family, bringing whatever, you have to be aware of these things. Oh, World Cup, big old conventions in town that slurp up all the other hotel rooms and you find yourself out in the sticks. Co-hosting is your friend. A day before an event, the second day of a developer summit and tutorials has worked really well for BeehiveCon in Tokyo, Ottawa, European cities, etc. But being across the street in a hotel or at the speaker hotel could be a great thing. So just make it convenient, but don't diminish the two events. Putting a developer summit on top of a developer summit, trying to split for the same audience is a really bad idea. So just really kind of balance all the factors. And there are public deadlines, the call for participation. Hey, get your things in. You've heard a few things this week from Peter and Christoph about EuroBSDCon. For those on the live stream, get those proposals in, please. Yeah, how long?
3 hours.
3 hours left, everyone, live stream. Okay, so, and then it closes in 3 hours. And then the response period, timely get back to people. Remember that they all applied and do get back. Hotel early registration, discount codes, room blocks, and all that stuff. But internal deadlines, venue contracts, deposits, confirmations, anywhere from up to the last week, like, hey, where are we at? What's going on? To, we'd love to have everything settled 9 months in advance, but that's just not a thing in all real practicality. Sponsor confirmations, sponsor payments, they're all over the map. You gotta be ready for that and have a comfort zone ready for that. Ordering swag, I'll get into a little swag things, but all this stuff has lead times, especially if it's t-shirts and sizing and all of that. And they're like, well, we're out of mediums throughout the country and they'll have to be longer for those, et cetera, et cetera. Food, you like to eat, catering confirmations, deposits, badges. Thank you. Thank you for badges, great word. And, Brian, John took care of them this year. Yes, anyway, badges, they need to be ready, and ideally you have a magical badge printer that spits them out live as people show up late and register today, but that's a whole different piece of hardware. It's probably unreliable, So, a lot of factors. Vendor payments, tax refunds, site updates. Oh, upcoming. There are a lot of conferences that still say coming in 2025, and just fix that, fix that. Publishing videos, like the recordings of things like this, how you live stream. Prompt reimbursements to all participants. This community, not BSD, all of open source and probably things like it, have a really big ol' ask about people fronting money and getting reimbursement. On one level, that's really cool. On another level, it gives you like fiscal oversight and stuff. And true story, someone bought ice coming to a summit in Portland. And it's like, can I reimburse them right there? Well, I can front them more money that I'll eventually get reimbursed. And then you find yourself spending hundreds of dollars, thousands of dollars, and waiting on reimbursement. It's like, yeah, okay, that's a big ask. For some people, $10 is a lot of money. For some, hundreds a lot of money. It's all relative, but I hope somehow in this broader community, we can address that and not be cruel to the volunteers. Any questions so far? Moving on. So comfort zones. Let's talk about the ultimate discomfort zone, money. Money, money, money. Money complicates things. It can screw things up. It's always a challenge. So again, small events are highly sustainable. Oh no, I spent 40 bucks on pizza and no one showed up. You have some leftovers. Great. I wish it was all like that, but it's not. I did a talk on exactly this, 20 years and counting. I did a second talk, 30 years and counting at FOSSI. The AV team moved during my talk such that there is not a recording of that. I have a funky phone recording I'll try to publish. That's probably not readable, but go ahead and search the title. Yeah, it was fascinating about, well, gee, Plug could go on for another few decades. I did it for 1 decade out of many. It's simple, rinse and repeat. So autopilot is great, but you run the risk of getting lazy and forgetting things and like all the things. But copy paste is your friend on the weekly calls. Yes, I copy the previous metadata, update the date, update the topics, and publish it. And it gives you consistency. That's it. It gives you consistency. So, rhythm is good. Changing leadership frequently can be terrifying, you name it. So, yes, events scale up and costs scale up. But still, costs are comfort zones for all involved. That's the sort of more organic aspect of it. So start your budget earlier and your prospectus earlier. Who is familiar with a prospectus? I'll show you what it is. But show of hands, prospectus, anyone? Oh, the conference chair knows what that is, but moving on. It's your price list. It is sponsor benefits. It is tiers of sponsorship. Be super clear. Try to remember how many free tickets are included at each tier. I should have a cheat sheet because I just go check the prospectus. This is right off the website. There's nothing secret here. That's right off BSDCan.org sponsors. So for gold, you get 5 passes and blah, 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 and a table and da, da, da. Tables need to be scheduled and requested and deposited and paid for deposits and blah, 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 blah. Different dollar amounts. The auction, the first year this team did it, 2024, had like 4 currencies. That's not helpful. It's like, oh, here's Tom with his British pounds and euros and all the things. And so even just talking to sponsors around the world, you deal with currencies. And yes, I shamelessly charge in dollars and sometimes euro and spend in Canadian dollars, and it benefits the event. So yes, pro tip. And another pro tip, rarely rely on ticket sales for any kind of thing. I mean, yes, a concert or a training thing where there's this literally 1-to-1 ratio of person entering whatever. But for an event like this, I don't think any of you want to pay 2,000 bucks to be here, like those super fancy conferences where it's purely ticket sales covering the cost of admission. And then in all practicality, yeah, try not to rely on just those payments. They're such a nice bonus to see we have all this extra money I didn't plan for. But from a fundraising perspective, yeah, don't count as little as you can on that because it's a variable. You don't know how many people show up or have to cancel or otherwise, you name it. So there's a small one. Starting from scratch is hard, although small is sustainable. So thank you, Dan Langell, for pioneering BSDCan, and a new team inherited it. And that's great because they're established sponsors, venues, you name it, vendors, all the things. Same with OpenZFS, I've been helping them out. There's a name, there's a tradition, there's like, you can adjust it, but I confess I'd be terrified to start BSDCan fresh with nothing. Yeah, exactly. So, and one small tip about fundraising. There are some sponsors who are super polite, and you've always just missed their deadline. Oh, but you're too early for next year. It's like, wait a minute, I've asked you every month of the year, and I'm too early and too late simultaneously. They're just politely saying no, and I get it. It just takes time to realize that's going on. So that's cool. I get it. Learn to invoice. Celebrate prompt payments. Yay, prompt sponsors. It can be 24 hours. It can be months. The bigger the organization, the bigger the bureaucracy, and they give themselves terms. Like, oh, yeah, net 30. I'm like, it says net 10 on the invoice. Like, okay, fine. So they pay when they pay. Fortunately, they've got their reputation to preserve. You've got yours. They'll probably pay, but still, it's like frustrating. So yeah, the bigger the sponsor. The more sensitive they get on their representation. We have an amazing sponsor who is nearly invisible because everything would have to go through their legal department. So it's bare minimum representation. And we're trying to find ways to say, hey, can we do this? Can we do that? And it's like, no, we're good, we're good. Which also brings us to the most awesome sponsors don't even look at the prospectus. They have their budget. They believe in what you're doing, and they will send over their budget. And you get these weird amounts of money. I'm like, I'm not arguing with it because they believe in what we're doing. And if it's $6,000 and it's not on the tiers, great. Yes, that's awesome. So, and a bunch of them, they don't need a table. They don't even whatever. They might not even have someone here, but they believe in what you're doing. So that is the chef's kiss sponsor. If they get way too hung up on the benefits and all that, you'll probably get a whole lot of questions and demands and all that. And it's like, that's cool. Just so it's been a wonderful, healthy balance. And thank you, sponsors. If you're watching, thank you. If you're in the room, thank you. You rock. And sponsors are generally from relationships. The summits in November in San Jose are great. And I've come up on stage with some of you in the room. And it took 3 years to land a sponsor that's been there every year, and thank you, that sponsor. But it's not just like, can we have money? Yeah, sure. It's that your kids might do that to you, but it doesn't work like that way. No. Remind them gently, but don't hound them. Trust that they'll come through, because often it's just silence, silence, silence. And, yep, you're good. Okay. For this event, mid-sized sponsors have been great. 5,000 US is an awesome amount of money because it's bite-sized for them. It's meaningful at this end. It's just awesome. I'd be terrified to rely only on like 20 grand sponsors. They're few and far between. They're probably taking a very long time to get you that money, and we all get to be really nervous as organizers. So the middle ground, the Goldilocks sponsor is awesome. And AI, yeah, no, I don't know how it could help me. I've seen people use it for letters to like community funds, like, oh, we'd like to blah, 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 blah. But in this crowd, I don't know how AI would benefit me reaching out to your employers, et cetera. And above all, he left. If you're not comfortable with fundraising, you're not comfortable with funded events, they're one and the same. And I watched an event in Portland just proudly have a team say, we all hate fundraising. It's like, and the event is gone because, I'm sorry, you just have to dive in and do it. And it's uncomfortable until it slowly gets slightly more comfortable. And it's uncomfortable until after the event and everyone's paid. And then you're like, okay, we did it. So public service announcement. I just threw this in at the last minute. Please support your BSDcons. Please, please, please. An introduction to the possibly right person at your company is plenty. You don't have to be like social. You don't have to pitch it. Just the introduction, because in Portland, we have Intel. Intel's huge. I know lots of Intel people who have never met each other. So if you have one person who gets to two others, that's golden. That is Better than me pressing my face against the glass, like trying to say, hey, BSDCan, hey. Yeah, so, and who do they pay? So, should you put it through your personal account? Yeah, $60 on pizza is probably okay through your personal account. Businesses, actually, there are very few genuine non-advertising sponsors, such that having it go through a business who's doing lots of other stuff and puts your conference through as like 1% of their annual turnover is really efficient, by the way. Create a nonprofit, use an existing nonprofit. That's an entire talk on its own, but there are different structures and different ways to do it. Back in the day, I'll just name I'll name the event, but not the organization, Meet BSD, handled by a company that it was effortless for them to put money through it. They're very comfortable receiving money and spending money. Great, benefits your event. In Latvia, there was the Open Source Association of Latvia, LACA. They registered as a nonprofit, a real junior basic one. Every single meeting switched to who's going to file the quarterly tax paperwork. We didn't discuss kernels, file systems, distributions, all the stuff. They started just worrying about that, and I'd argue it destroyed the event, the organization. So, and in all these financial structures, there's the control, the nimbleness, the ability to reimburse someone for $6 in ice immediately, because, well, they got the ice, and I'd rather forget about the ice for tomorrow and all that. Or the whole promise of fiscal oversight and verification that everything's above board and that the $6 of ice is not fraudulent. And just one quick soapbox. The tax authorities of your country are not going to like smash in a window and first say, hey, you violated that open source license. Step away from the computer. Or, oh, your $40 in pizza is questionable. They're going after huge fraud. So all these mechanisms that are protecting from massive fraud, punishing the person getting you ice at the little corner store on the way to the event is cruel. It's just cruel. So the big old huge conferences in Vegas, yes, they need auditors. They need all the things. It's not yet us. Okay, so then of course, contracts, deposit. What's that? Do we look forward to having that problem? Okay, maybe. Yes. And we get paid huge amounts of money for that infrastructure. So it's a lot of work. This is all voluntary. So lawyers, insurance, banking, international banking, banks who receive payments but don't make it clear who they came from, and all the things. It's educational. And luckily, that's not what this talk's about. So we're moving on to questions about fundraising. Anyone? Anything? Okay, good. Y'all are experts. You're now on the planning committee. Scheduling. 40 to 50-minute talks are, you can put a bunch in a day. 3, 4, don't pack that schedule. Leave time for social things. For after work events, well, like Portland Linux Unix group, yeah, 90 minutes is about right. There's no hard stop. Maybe the room will throw you up, but people, if it's after work and haven't had food, yeah, the beer 30 kicks in and they really just want to reconvene at the pub you've chosen, that kind of thing, or church, or whatever you do. Absolutely leave time for informal time. Don't try to make formal things informal and vice versa. Just separate them and everyone will be happy. Leave a big old gap on the schedule of just time to talk. It's awesome. Cadence. As someone pointed out, weekly is biblical. 7 days, Monthly is tricky. First Thursday plug always fell on 4th of July almost each year. Well, do you then try to find a room Wednesday, because you've been Thursday for years? Do you skip a month? Like let's just say leadership calls and other various things. Skipping a month means it's been a really long time since you've met. And it's tricky. So weekly is good because if you miss one, well, and I don't recommend that for your local BSD group, but key point, think about the cadence. Annual makes sense for an event like this. No, we don't want to do this every few months in the same spot, same everything. Then the medium-sized events, biannual, yeah, there's a place for all of that. So just think about the cadence. Registration, we've probably all heard of Pentabarf. I think BSDCan used Pentabarf, which I think is out of Fosdem or somewhere. Yep, cool. They intentionally chose the worst possible name. We're using Indico. Are there any Indico users? Well, you're all Indico users if you registered. Any administrators in the room? And are we happy with it? So if you showed up, it's doing something right. Eventbrite, SimpleTix, those fees get really high, especially if you have donations. I go to an organization and something comes off the top and then it goes to a vendor and you're like, wait, we had that money. For Shipsy, I use SimpleTix. And I looked at all of these for a different talk, all these different services. Some of them play bank. Some of them pay you immediately. Some of them do all kinds of different stuff. So I'm glad there are options. And at some point you have to take money. There's SquareUp, there's Stripe, and that's a whole different topic. But just be aware that there are choices and options. Swag. Cheap swag is trash. This 2013 BSDCan bag fits beautifully in my side pocket across from the water bottle. It folds up, and it's great when they say, oh, you have to check your bag, and I slip my laptop in there, and I go on the plane, and I don't destroy my laptop. It's quality made. It washes pretty well. Makes swag practical. It's an umbrella for places like Ottawa, it seems. That's cool. That's pragmatic. It's bright. Distinguish your bag. I'm learning to love coasters. They're cheap, they're durable, they're light. Bringing hundreds to Ottawa is effortless. They came out nicely. Does anyone need a coaster? Because they have an extra bonus. You need a coaster? They fly. Stickers. Stickers are small, great, awesome, yay. There's some runs at a fest. ISC sent some, there's some spares. I didn't stress one bit about bringing these. Laptops and stuff for the AV team, that I stressed about. But avoid batteries. It's e-waste. Those little flashlights that barely serve as a flashlight and all that. And then maybe the battery kind of makes that white gooey yuck, yuck, yuck. Just durable, pragmatic, please, please, please. Sizing is tricky. Shirts. Luckily, we have mathematicians on the BSDCan team, and they have these projections of how many extra shirts for late registrants, et cetera, et cetera. So things to worry about. Ooh, does anyone have the tote? The tote, the tote, the tote. We've got a tote there. Can you throw that tote to this guy? Notice something very important about the tote, or hold it in front of the camera. There is no date on the tote. It is evergreen. It is timeless. It is attractive, so it's also useful. So swag, it can be awesome, and you see the old Sun employees with their little badge tags and other goodies from all that, and mug. Make swag durable, please. Oh, program committee notes, yes. There are times to have a completely open call for participation. There are times to have a curated event where you know that certain people can talk about a topic best and just invite them, and your audience should recognize that, yeah, those are the experts. Food. There's a movie reference, and hopefully you Gen Xers recognize it. We have both kinds of food, meat and salads. Wow, there are a lot of allergies. I had not heard about coconut allergies. I did not, and now I'm aware of them. And we all have our preferences, issues, allergies, whatever. And oh my gosh, the restaurants of the world and caterers of the world either get it or don't get it. And some label all the trays that come in, and they remove all the labeling and put them out, and it's like, so that's one to just be aware of, and wow, vendors are inconsistent on their handling. Drinks, I remember that in the 2000s in Portland, like lots of concerns about alcohol at events because, y'all aren't mature enough or whatever. It's like, you're the only people I want to drink with, actually, because there's a bar down the road, but I've never been there. I want to drink with you, just a simple, nothing extreme, but, I like you. Inclusion. Comfort zones can drive this. Some people really don't like loud droning noises or adjacent noises or you name it, just all the comfort things. Codes of conduct, don't make me tap the sign. You're being obnoxious, you're antagonizing the staff. Like, this event has a code of conduct, and I don't think we've had to use it this year, and that's great. Thank you. You rock. Yes, for the win. Streaming for inclusion. Not everyone can be here. I picture a world where, from the movie, and I did put a copyright attribution in there, you have this sort of, one event had Dan the robot over some nifty thing, and you want to involve people. You want them to participate in the discussions. You want to reduce that distance, because then you're only down to time zones and languages. Yeah, don't penalize people if they can't come. It's expensive. Some don't have passports, as we've learned. Some can't legally travel to Canada if they said the wrong thing at the board 10 years ago. Travel grants are something this group's been pushing for, and they're working. We got some people who wouldn't be here otherwise, and they've been extremely involved and gave like lightning talks and found a place for them in the schedule. Yay. Streaming notes. This is a discussion Patrick and I can discuss offline. That's a whole different talk. Renting versus owning. Unique components might not be available in that town you're in, and cameras might show up in a foreign language and all the things. Just ask us separately. Team building. Dan pioneered, hey, carry a box. It's a great way to, very easy comfort zone, get involved in the planning. Some organizations have a rule that you've had to help out the previous year before you either get a title and do more and all that, because you really have to test people out, because people are all over the map. They're wonderful, we love them, but they're not always reliable. Some are amazing. I'm looking at some amazing people. I love you. Yeah, we all have to prove ourselves, and let's ease into hidden costs. We've got the office in Hawaii. Yeah, getting there is expensive. Everything you put in your mouth is really expensive. Everything's expensive, but the office is gorgeous and free, and at the university, and a long drive to a venue, up the mountain, whatever. Gorgeous view, long-ass drive, early flight. It's tricky. Do you rent a bus? It often is very good to rent a bus. It's like the most efficient thing versus a whole bunch of ride shares, etc. Speaking of buses, bus factors and single points of failure. I don't have answers. Mentorship, maybe starting right here is a good start, because maybe any one of us on the organizing team could be just stuck at our hotel because, or at the border at home because of airplane trouble, whatever you name it. There were travel issues this year. Redundancy is hard for especially specialists who do these things and are doing it well. It's tricky. I don't have a magic wand, I'm sorry. Venue surprises. Oh, we didn't tell you we closed that room we're remodeling, and I touched on that earlier. Some give you good warning, some don't. Uncomfortable surprises. Yeah, the money's coming, and it'll come when it comes. And, true story, someone last year, year before, it was really hot, they're protesting other crazy stuff. They walked in, vomited, passed out, probably heat exhaustion, and it was handled beautifully. And many of us, most of us, found out after the fact because it was so well handled. The team in front did the right thing, called the right people, and that's as good as it gets. People can be irritable, disruptive, you name it. Famously, a large song festival had someone steal the cash box long before PayPal and Stripe and all this stuff and disappear to a certain country in Europe. And that put such a cloud over the event, they didn't have it for decades. So is there one person to blame? Is everyone to blame? Don't punish literally their kids organizing a follow-on event for whatever the hell happened back in 90-something. It's like, oh, vicious rumors. Ask me after about that one. That's a fun one after an event. Memorials. And I learned this at Plug. People pass away. We've learned it at this event. People pass away. And doing a moment of silence is never fun, but it's something that comes with the territory, and just be prepared to do that. So, but yet we continue. We find ourselves proselytizing these huge asks to people like you because there are rewards. There's a lot of stress, but those rewards are priceless. And the moment heck, those were good times, and that swag I'll remember to this day. And conferences that no longer exist, well, they were good times, and maybe they created a software project that is now an industry. It's like, so that is awesome. And I'm wrapping up, don't worry. A chair of this event introduced me to FUBU, For Us, By Us, which is a clothing brand. And I've seen events where every single person there, including in the kitchen, we're part of the community. When you have a storage engineer in the kitchen cooking up, asking questions from the kitchen over the wireless. It's great because everyone wants to be there, not the booth staff missing their kid's soccer game, like, let me scan your badge. No one's happy from that. Nobody. So this event is literally as much as we can, it's for us, by us. We didn't do the catering, unless there was someone local who happened to have an aunt with a restaurant, we could probably pull it off, but anyway, aim for that, because paying through the nose, full retail for everything is just harms the community, I'd argue. So you probably have your own reasons here to insert. So get organizing, ask me questions, please reach out. I'm pretty easy to find. Email, fine, I can give you my phone number, I've got cards, whatever. Just please, in your neighborhood, your city, your town, your school, whatever, have a club, have a meetup, find that little meetup site, whatever, and just say, hey, we're going to be there at 7. We're going to talk about BSD Unix and all that. Anyway, that's what I've got. Any questions? Yes, sir.
Is it possible to run an event if one is not having enough humor sense and creativity like you?
So the question is, can they run an event if they don't have enough humor sense, thick skin, patience, stubbornness? I was terrified. Seriously, I had a little publication in the 90s, and I went up before a user group, and I could barely speak. It's all comfort zones, all of it. So start small with whatever your comfort zone is, and take a little baby step each time, from showing up at a restaurant to talking to the manager about borrowing a space in the restaurant. You'll find that it's all the same reproducible skills, and they're just skills. That's it. It's just all comfort zones is my answer. Other questions? How are we on time? Over. Hey, for 120-something slides, I hope I did okay. Well, thank you so much. Reach out. You rock. And thank you all volunteers and sponsors and attendees. You are awesome.
Hello everyone, I'm Alfonso, a FreeBSD developer, and I have some project with the FreeBSD Foundation to improve the vision accessibility. This is my first time in person at BSDCan. I had a talk online 6 months ago to present a new CCTL interface. I created also projects for CCTL, so I hope to be present them here in the next years. I will present a personal project, Partenope, a FreeBSD OS installer. We will see motivation, examples, future plans, improvements, and new ideas. Why to create a new installer? Why not to improve BSD install? Briefly, Partenope has different ideas, different design, and different implementation. I presented the motivation at Zagreb during the last EuroBSDCon, so now just a quick recap. BSD install is a sequence of screens, components or steps to set networking, time, date, and so on. Each screen creates a command line for dialogues, runs dialogues with the command line, gets the output of dialogues, and finally runs a command. BSD install depends a lot on the dialogues command line. 4 years ago, I replaced dialog with BSD dialogues as the BSD install front-end user interface. At the left, you can see dialogues. At the right, BSD dialog. The challenge were Petitiona, Mixed Gauge, and to create a command line quite same as dialogues. It is a quite old command line. Anyway, the task was really interesting. I like BSD install, it just runs. So I had some ideas to improve it. For example, BSD install uses PKG for 15 years. For example, BSD install uses PKG to install documentation at the end of the installation, as we can see in the dialogues at the right top. And we can use also the port collection. So why not an improvement? A new component to install and set up graphical environments, or a new component to install and set up a vision accessible environment. For example, we could install a Magnify at the left to a high contrast themes at the right. And another improvement. Let's say you select the date and then go to next screen to select a time. We are human. I want to go back to check or reset the date. Why not a new previous button to go back to the date? I can't implement my ideas for a personal problem. Another developer finished the replacement. I started to work again on accessibility. BSD install uses a text user interface. Text user interface is a well-known accessibility problem. Screen readers cannot read a text user interface, so a blind user cannot use the installer to install FreeBSD. What's the problem? Really, the accessibility deserves a talk. Anyway, just for curiosity. A screen reader reads elements on the screen and sends them to a speech synthesizer or a braille display. The screen reader cannot read a text user interface. Why? Because the screen reader sees and reads what the text user interface is really, a terminal full of text with the codes or human text. But the real problem is semantics. We can see graphical widgets, a blue background, a dialog type, a dialog border, a dialog title, text inside the dialog, 2 buttons with the focus on a button. These components are just text in a terminal, not like widgets in a graphical library. The screen reader does not know what is a border, what is a button. So a speech synthesizer would say for the top border plus dash 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 plus example plus dash 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 plus. Also, no buttons. The no buttons is just text. The screen reader does not know where is the focus on buttons, and the blue background is just a space characters. The screen reader does not know what is useful text and what is useless text. So we could send a useless space character to a display braille. Why not a new plain text CLI accessible front-end to BSD install? Some components of BSD install already support a multi-front-end approach using the dialogues environment variable or the Xdialog hard-coded. It's correct. If you type on your FreeBSD computer pkg install Xdialogs, then run BSD install docs install -x, you can see docs install with a graphical user interface. At the left, we can see the command line of the previous documentation install dialogues. We can set the blue dialogues variable with dialogues or Xdialogs. The command line are quite the same. At right, you can see the dialogues in text user interface and the graphical user interface. You can also use BSD dialogues or Zenity. So again, why not a new accessibility CLI front end? I wanted to create an accessibility dialog or CLI dialogs. However, BSD dialogs depends a lot on the dialogs command line. As you can see, adding a new front end to BSD install with the command line completely different from dialogs is very difficult. Adding a new front end for a screen reader is hard. Adding a new web front end is hard. Adding a new graphical user interface front end is hard. Really, BSD install uses BSD dialogs since 4 years. Anyway, BSD dialogs has a quite same command line like dialog. Adding a new text user interface front end is hard. So I created a new installer. I can also add the other feature, not only front ends. So Partenope. Partenope is a two-step installer written in Lua. Step 1 creates an installation file. Step 2 reads the installation file and performs the real installation. As we will see that the work is for step 1. You can run only step 1 or you can run only step 2. You can create an installation file one time with the step 1 and reuse it many times with the step 2. You can create an installation file and decide later if, when, and where to use it. The installation file is a communication file for the step 1 and the step 2. It is also a standalone installer. It don't need a step 2. You can run it by Lua, installation.lua, or the FreeBSD Lua version in base, flua installation.lua. Step 1 can also create a shell script standalone installer, installer.sh. To run, just type installer.sh. To create an installation file with Lua is quite trivial. Feel free to let me know if you need a new file type. For example, I see Ubuntu uses a JSON file. Of course, installation file as a standalone installer or use it on another computer is for expert uses. Anyway, I think anybody could be interested to know the commands to install FreeBSD. I assume this is a feature of some Linux distros. At the left, we can see installation.lua and at the right, installer.sh. Properly, the main reads a configuration file at startup, then calls step 1. Step 1 creates the installation file. Main calls step 2. Step 2 reads the installation file and performs the real installation. The configuration file is a normal Lua file. Anyway, you don't need to know Lua to set up it. As you can see at the right, it's just a name equals value file. We will see a lot of examples of configuration. Now, just for curiosity, the full file for a few seconds. In blue comments, in black variables, and in pink values. You can see the most part are comments. We will see many screens and the feature. Don't worry, this tool is small and simple. You don't need to know Partenope is a two-step installer. You don't need to touch the configuration file. You don't need to know Lua to set up the installer. The installer also provides a simple installation mode. So, getting started. To use Partenope, just download the project and run it, no dependencies. It uses flua, the FreeBSD Lua version in base. You can run the installer in a graphical environment. You don't need an ISO to run the installer. The general case is Partenope runs on a FreeBSD system and install it and install the new system in a destination directory. Of course, you can run only step 1 to create an installation file. Simply reply no in the confirmation dialog. Or if you want to run only step 1 using a configuration file, copy the default configuration file, set step 2 false, and run Partenope with the customized configuration file using the Partenope conf environment variable. If you want to run Partenope in an ISO, you can download a FreeBSD image. The repository provides a build Partenope ISO.h shell script to create a new ISO image. Just you should pass the downloaded image, FreeBSD image. Of course, the script extracts the FreeBSD image, copies the installer, set Partenope like the default installer, and builds an image. The script takes 30 seconds to boot an image on this laptop. See, Parthenope, FreeBSD, your downloaded image. I tested the ISO in a virtual machine, VirtualBox or Beehive. Now I consider an ISO a special case because the installer has to set up also the live system, not only to install a new system. Anyway, to choose the default case means just to choose the default configuration file, no operation change. So let's start to use the installer. Parthenope starts with a start menu by default. You can enable or disable all the screen by setting the configuration file. Of course, you can set the screen title. The menu provides an help with F1 key. The help describes navigation buttons are key, description of step 1 and step 2, that is configuration and installation, and how to read the logging file. Really, the start menu has a simple menu and an expert menu. This menu is the largest operational file of the installer with just 285 lines of code. The menu has 3 buttons: select, shut down, and reboot. Let's start to see some menu item. Internationalization, now only Italian. Of course, when an Italian string is missing, the installer chooses the default English string. My goal is to provide a translation at least for the simple installation mode. A challenge for internationalization could be non-English and non-Latin fonts in the virtual terminal. I found a paper for Chinese, Japanese, and Korean to read. So far, I can't use an accessible font in the virtual terminal. Anyway, as you can see, no problem in a graphical environment. Let's go back to the start menu. We can start BSD install. Parthenope has to start before to BSD install for accessibility. We will see a demo for blind uses later. We can select icon tracks to switch to a black and white theme. This is an accessibility feature. We will see more improvements later. And we select advanced to go to expert menu. If you have already an installation file, you can select file installation to provide a previous installation file. Of course, the installer will skip step 1 and step 2 will install the system directly. Select login to see login option. The installer provides multi-login levels, now level 1 for system admins and level 2 for developers. Level 2 is the default. Of course, you can change using the configuration file. The level 1 shows commands, return values, output and errors, and UI input and output. Level 2 shows info of level 1 and info for each function called. I'm going to replace the logging radio list with a checklist to allow you to select which information to save. BSD install has a shell and the live system buttons at startup on the top. So I did the exit and the live system option in the expert menu. The exit option simply terminates the installer by calling OS exit 0. Live system option start a new shell. And if you type exit in the shell, you will go back to the installer. Of course, your previous configuration are still preserved. Select the setting to view and modify the variable from the configuration file in a form. I don't know if it is a user feature. I added it for debugging. And now installation. This is an installer. Select install to begin a text user interface installation. Now the step 1 starts. It collects the user input to the screen to create an installation file. Each screen has the previous and the next button. You can navigate the installer. It is possible because step 1 doesn't execute commands. It only saves the user's input. Each screen has a number in installation sequence. Each screen includes a restart button to open a menu, to go to home, to restart installation, to shut down, and to reboot. Each screen provides an help with the F1 key. The installer provides some multi-installation modes, auto, easy, and expert. Auto installation creates the installation file in under 1 second, reading the configuration file and auto-detecting hardware. It is not perfect, we will see some improvements later. Simple installation for a desktop or laptop, the same computer where the style is running. Step 1 uses the minimum possible number of screens. Let's see quickly the test screens of the simple installation. 1, select the simple installation. 2, keyboard. 3, location and time. 4, hostname. 5, networking. 6, partitioner. 7, root password. 8, uses. 9, desktop. And 10, confirm configuration. Let's see simple installation of the details. Keyboard, now a menu. I can do it interradially, standard to add the form to test the layout. Time info, the screen displays some time-related information. Why? What I want to see when I install FreeBSD. And the menu allows to open some sub-screen. To set time zone, time and the date. If the time info menu is false, the time info does not display the menu, and the sub-screen begins normal navigable screens. The time problems, the user sets the time during the step 1, it will become game obsolete in step 2. So step 1 uses diff time of Lua to store the user input and the system time difference. And step 2 uses the V option of the date to apply this difference. Of course, this solution runs in a simple installation. I assume the installer will install it on the same computer where the installer is running. Hostname, just a simple form. Networking is a work in progress. My goal is to simplify BSD installer dialogues. I added USB tethering if the driver is not available, and because I had a problem with the boot-only image some months ago. Partition, ZFS, and boot are work in progress. SADE, FreeBSD BSD installer partition is written in C, uses libgeom for geom and libbsd dialog for user interface, and it provides auto partitioning. It is important for simple installation. I replaced the libgeom calls with the strings of gpart commands to run it in step 2, thanks to string list. Anyway, I would like to use the code of the partitioner with other front ends. SADE has several feature requests. Geoman provides interesting feature useful also during the installation. So mainly for the multi-front end, I'm going to write a partition in Lua. Later I will take a look at ZFS and boot. Root password, just a form. The password is stored encrypted by default. Some checks are performed. Uses a form to add a user. In a simple installation mode, you just provide a username, a real name, and the password. Of course, the missing user fields can be set via the configuration file. A user management menu is possible. We will see it in expert installation mode. Desktop, just a simple checklist to select a desktop environments and some graphical tools. They are good tools on my laptop. The GPU is detected and the drive installed. Maybe a problem with the NVIDIA graphic card. Partenovo uses PCConf to know the GPU and the firmware get to know the package of the driver. Anyway, firmware get handle only AMD and Intel graphic cards, not NVIDIA. So, for example, BSD installer desktop script asks the user to select the version of the NVIDIA driver. But I found a solution. I found a web page from NVIDIA. It lists the drive version and the list of supported GPU for that drive. So I create a table to match PCI ID and the NVIDIA drive version. So I can auto-detect the NVIDIA card via PCConf and to install the driver with the table. The problem is the NVIDIA file has a copyright but not a license. Is it BSD licensed? I don't know. And the last step 1 screen, confirm installation. After the next button, the step 1 writes installation file and exit. Step 2 starts, read the installation file and show a confirmation screen. If yes, a mixed gauge shows installation progress. Each error is in user interface with the error message and the command. And complete the simple installation. Let's see the expert installation should be similar to BSD install. Keyboard, like simple installation. Time info screen with the more info and the 2 new subscreens, real-time and network time protocol daemon. Host name like simple installation. Partition like simple installation. Base, that is PKG base. In BSD install, PKG base is written in Lua. I can reuse it, of course, with some modification. And to do is PKG base works with the Makefiles, so the Makefiles option must be integrated in the Parthenope configuration file. Root password, like simple installation. Uses are handled by an user menu management. Of course, you can add a new user with the add button, and you can select a user to update and delete it. Services, a checklist to select the services to enable. Hardening, a checklist to select the security option to enable. GPU, the screen detects the GPU and show it like a tip on the top of the dialogues, auto-detected in this case AMD. And enable by default the item in the menu, AMD. An expert user can select another GPU. If you press 1, you can know extra info for your GPU. Desktop, like simple installation. A logs, a checklist to select if the log file and the installation file should be saved on the new system. And the confirm installation, like simple installation, and confirm configuration, like simple installation. Step 2 starts with the confirm installation screen, and if you press F1, you can see the commands to install FreeBSD from the installation file. Step 2 uses a mixed gauge to show progress by default. Let's go back to the expert menu to see other options. Expert menu, then select installation mode, installation command, execution, and display mode. We have 5 modes for the step 2. 1, the default, the mixed gauge. 2, a verbose mode, just a simple bar to display every being executed command. Debug, to show every executed command. After each command, we can see the output, error, and output. 4, devel mode. Devel mode opens a form for each command. I can change the command, execute the command, go to previous command or the next commands. Devel mode is very useful to test the installer in ISO live system to avoid to build a live image every time. And 5, raw mode to show commands in a terminal. And the last screen, complete, like the simple installation. Interactive and non-interactive. Interactive, what the user should choose. Non-interactive, what the user should not choose. We have seen some options. Anyway, each screen of step 1 has 4 variables. They are important because they can create the installation file. The variables are described in the configuration file like comments. I will describe them with examples. If a show is true, if a service show is true, step 1 will show a screen to select services. If show is true and in default SSH is true and the dump dev is true, the screen will show SSH and the dump dev enabled by default, as you can see by the red arrow. If show is false, step 1 will not show services screen, but if in default SSH is true and the dump dev is true, step 1 will use default values as they were selected by the user, so written in the installation file. If services is false, the screen is skipped and nothing is written in the installation file. Command is written as is to the installation file, and this is the priority of the variable. Services command, services default, and the services show. Implementation overview. This is the installer in an ISO. As you can see, this is a simple and a little installer. Configuration.lua is the configuration file. Logging.lua for login. Parteno is the main. Share.lua is just a file with a function to execute commands. Start menu.lua is the start menu, both simple and expert menu. The I-89 directory is for internationalization, now only Italian. It is very simple. If Italian dictionary has a hello word, returns the translation. Otherwise, return the key, the English string. User interface directory, now only one front-end is available, the text user interface, implemented on BS dialogues. Except this directory, the installer does not know what is the front-end it is using. User interface provides an object-oriented API. The main creates an UI object and passes it to other installer components. As you can see, it is a general object-oriented API for user interface. Okay, this is to create a menu. Create a menu, pass the list of items, add to buttons, and the show function. I would like to replace BS dialogues in the future, and I should improve the API, the user interface API, to add other front ends, CLI, graphical user interface, and web interface. We will see a preview later. Step 2 is only one file. It is just a loop to get strings from a sequence and execute them. The step 1 directory includes the screens and the step 1 manager, step1.lua. So to add a new screen, we have to set some variable. Actually, the screens are not standalone. They are handled by a manager in a framework. So to add a new screen, we have to set some variables and to implement some function. For example, a few variables to link the screen with the configuration file to show the command line, the default value. We can set distillation mode, simple, expert, or both. Some variable for the step 2, in this case, label and group. It is just a graphical user interface property. The order of execution in step 1 is not important, but in step 2, the order of execution is important. For example, before the partition, then networking, and finally desktop installation. So we can set priority with the priority variable. Error is not implemented. It defines what you should do step 2 when an error occurs, ask, warning, fatal, and so on. You should also provide a private variable to store the user input, because this is not a navigable installer, a string to show to the user for F1 help message. And you should implement an init function, a reset function when the user select restart and reset installation, clearing all settings. A function to build and show the user interface. A function when the user interface is disabled, show is false, or the screen is expert in a simple installation. And of course, finally, you should implement a function to return the command. Which screen has the most lines of code? Use this management menu with just 255 lines of code. The framework handles most of the work. I could install on my laptop with the graphical environments. The main task of the installer is to take user input and to write a file. I don't need to create an ISO and start a virtual machine all the time. I can use the step 2, the well install mode, if I wanted to test a live system. I found a list of user requests for BSDCan. I implemented this feature in just one evening, so I presented the talk at your BSDCan. In the last 2 months, I have wrote everything, and the installer with the text user interface is almost complete. Configuration and BSDCan feature. BSDCan provides a jail option to create a new jail. For example, BSDCan jail my jail. It is implemented like a shell script. I did not add a new component in step 1 because this is a configuration matter, not an operational one. If I want to create a new jail with the Parthenope, I just can set a configuration file to define what to install, where to install, and how to install. Anyway, I created a configuration jail.lua to replicate BSDCan jail, so you can set a dest dir and to create a jail with this configuration file. BSDCan provides a command line and a lot of environments variable. Parthenope only a configuration file by design. For example, BSDCan hostname, you can disable start menu and all the scripts, all the screens except hostname, and run Parthenope with your customized in configuration file. Currently, I can reproduce, simulate all the features of BSDCan with Parthenope except ZFS and pre-install and post-install option. Of course, they will be implemented in the future. If you think that a command line interface or environment variable could be useful, it's okay. Feel free to let me know use case. I can add them to Parthenope. I create BSDCan.lua to get the BSDCan command line and some variable and some environment variable and to simulate them with Parthenope. For example, BSDCan.lua hostname, it runs Parthenope only for hostname. Some to-do, work in progress, and ideas. Speech synthesizer installation. Start menu will play 3 beeps by default in the future, so blind users know they can start the installation. The simple S and enter key combination starts the CLI frontend with the speech synthesizer. This is a feature request from the FreeBSD accessibility wiki page. Let's see a demo.
Starting operating system installation. The installer provides a command line interface, CLI, for menus, questions and input forms. Press Ctrl and H to know the command keys for the current CLI element. Press F1 to help about the current configuration. P, previous, R, repeat, N, next. Input form. Write a host name for this machine, then press Enter key. This is an input form. Command keys. Write text and press Enter key to finish your input. Ctrl and S, spelling of the written text in the form. Write a host name for this machine, then press Enter key. Help message for host name configuration input form. A host name is the name of this machine/computer/system for networking communication. If you are running on a managed network, please ask your network administrator for an appropriate name. Write a host name for this machine, then press Enter key. Press Enter, written host name, foo.bsd. Complete host name configuration P, previous, R, repeat, N, next.
And This is just a preview. Okay. Accessibility as metrics. Here, this is the ideal solution, a CLI with only plain text in one dimension. One dimension is image to having your eyes closed, while someone reads a book to you, you will hear only a continuous stream of text. For example, at the left, you can see Firefox, a web page with two-dimensional information. At the right, the same page in one-dimensional information with the browser. And for the FreeBSD port collection, at the right left, port config, a text user interface in two dimensions. And at the right, port option CLI, the same port configuration in one-dimensional information. FreeBSD has not a speech synthesizer in base. One solution I like could be to use the DVD image with this package. Web installation. Now a simple web server is started using Netgate to serve a web page. This is the page. I found an interesting project for the FreeBSD Foundation to provide a web installer. This is just some preview, some screenshot from the project repository. The project is written in Lua, all stack is BSD licensed, no dependencies, start a web server, saves user input in a configuration file and performs the real installation reading into configuration file. Of course, I can use this project like a web front-end for Partenova. Graphical user interface, graphical installation. Some BSD install screens already can use dialogues. The partitioner could be the challenge. Anyway, I would like to create a GUI similar to Calamares. FreeBSD has not a graphical libraries in base. Anyway, some solutions is possible. Just one option, DVD image, SCFB, and XOG minimal. Some to do for accessibility. Now Partenova provides a black and white themes. Accessibility needs to be improved. Not everyone can see the full screen clearly. Not everyone can see all the colors. So I will add an option to provide the feature described in the FreeBSD Accessibility Handbook. And I created new themes for the text interface utilities. Feel free to let me know if they don't meet your needs. Of course, we can find a better solution. And out of box, just an idea, post configuration. The goals of auto installation is to provide a full functional system with no user interaction. However, some settings must still be manual, for example, root password, Wi-Fi, and so on, before installation in the configuration file, after installation or at the first boot. Another case, let's say we want a desk to install FreeBSD on laptops here, like during Linux events. I would like to provide a ready-to-use FreeBSD laptop after the installation when the user went to home. One possible solution could be the out-of-box like commercial devices. Let's say my devices, an Android phone, Windows laptop, an iPad, this is a laptop with Ubuntu. The device is provided with the operating system pre-installed. At the first boot, it asks username, password, Wi-Fi, location, and so on. I can implement this feature in the installer. I could change or to improve the installation. I can add a new out-of-box post-configuration mode. A checklist, I can provide a checklist to select the settings to be completed at the first boot, networking, root password, time zone, location, SSH, and so on. The installer already can install and set up a graphical environments. So this post-configuration can be also in a graphical environments. Just some preview, some mock-up with Python, tk-inter to select networking, root, password, and date, C and GTK, and C and the nuclear. This feature is just an idea now. It could be an interesting feature in the future. the roadmap. The phase one is to complete the installation with the text user interface. I wanted to implement SAD in Lua. I should integrate PKPG base and implement a network manager. And I would like to provide international JSON at least for simple installation mode. Phase two, to create an abstraction layer for front ends and to implement an accessible CLI front end and a web front end. And the last phase, to implement a graphical front end. Just some fact, what can I do with the Parthenope? What we saw today, partition and work manager in progress. Can you add this feature? Yes, feel free to let me know if you have a good idea, so on some improvements or some requests. This is the project. It is in the devel branch. I will move in the main branch what the installer is read for everyone. The timing. I hope to finish this project by this year, at least the text user interface version. Next year, I would like to focus on other projects. This code is wrong, of course. This is my first scripting project. I like to pass a software to a compiler. Why Lua? I don't have a strong opinion about programming languages. Anyway, I choose Lua mainly because for the web installer and for the object-oriented API. Will be a port available? Yes, it is in the to-do list. Anyway, this project has not dependencies, just download and use it. This is a new project, not an improvement of BSD install, not connected like BSD install. What is the difference between the run-only step 2 and a standalone installer? The step 2 adds logging and the user interface if enabled. If logging and the user interface is disabled, step 2 and the standalone installer is functionally equivalent. Okay, thank you. Finish installation.
How can we get this in base?
You are too far. Can come here.
Oh, okay.
I have to.
How can we get it in base?
How can we get this into base?
In the base.
In the system.
This is a question for core team, release engineering.
Yes. Yeah, so
this is a personal project. If somebody who is in base, it's okay.
It seems like what you have implemented is more advanced than what we have in base.
Okay. Okay, actually this is a personal project. What I want, while I install FreeBSD, if the core team, if the release engine within base, it's okay.
I can speak as core team. Actually, the core team is not who decides that. It's the community, and the last word is by release manager. It seems that community likes your project.
Yeah.
So, yeah, you should talk to Colin and start working to getting that into FreeBSD.
Okay. Yeah.
Please.
Actually, BSD install was just a menu to install a desktop on my laptop. Then now it's in base. So it's a normal path.
Thank you.
Thank you.
Thank you.
Alfonso,
Another question.
you go ahead.
Do you know what regressions currently exist from what we had in base so far, what we would need to build out?
I don't know. Don't know. To test.
Okay, thank you.
To investigate.
So Alfonso, I know you're also working with BSD Dialog to add a full desktop installation.
Yeah.
And
It was just a menu.
Yeah.
Then Baptiste asked me, do you want to implement other dialogues to replace GNU dialogues? And I implemented all dialogues.
So you're working with BSD, the current BSD install, and now you're working with Panthenope, however you call it. You're doing 2 installer projects right now.
Yeah.
How much better is it working with your stuff in Lua versus the old stuff?
What is it?
How much easier is it for you to work with Lua?
On this one. This is just to write. For BSD Soul, every time you want to add a new feature, you have to create a new image to launch a virtual machine and do test. If you find a bug, you have to recreate an image and to restart a virtual machine. With this one, I just need, I can run this in my desktop.
Can you make the font bigger?
Yes. Okay. No. Anyway.
Maybe it's better we talk after.
Yeah.
Yeah.
Anyway. Close. No, it's a stop at this screen. Okay. I can code this tool in a graphical IDE, and I don't need to run every time, to build every time an ASO. Just for example, for example, I can run this tool in my XFCE. Configuration. Okay, install, auto installation, next, no, okay, and now you see, actually, MIT, I can install the system on my computer, and the hard work is just live. installation tool. That work is just to create this file.
Yeah.
I still created the installation file. I don't need to create any ISO, so the bug is very fast.
Yeah, that separation is nice.
The desktop, the script to install a desktop, KD desktop is still a work in progress on BSD tool. And here is just to write a string in a file. Okay, thank you.